All right, well, thank you so much for being here today. So to kick things off, I'm really honored to introduce Michigan Tech's President Kovac.
I likewise wanted to welcome you to our campus and thank you for joining us and talking about the discussion you're going to have today. You know, being located where we are, right, the Great Lakes is woven into everything we do, and oftentimes it's one of the reasons that students come here. So whether we're talking about the health of the Great Lakes or the transport on the Great Lakes, that's really part of the DNA of Michigan Tech. But also we're a public technological university in the state of Michigan. So the auto industry and the transportation industry is also part of the DNA of us as Michigan Tech. And so our researchers focus on things like autonomous vehicles, like electric vehicles, and also like transport on Great Lakes. And that's why for me, your conversations today are so important because it really reflects the confluence of the two main thrusts of why in 1885 Michigan Tech was developed. And in addition to that, let's talk about transport and the autonomy, but also guys, we talk about the workforce, which again is the other big part of our mission. So I just wanted to tell you how much we appreciate the fact that you've all come here to discuss these topics, which really represent the heart of Michigan Tech. And I wanted to thank Tim for his leadership. I started 4 years ago. My first event I was at was right down there in August. They designated this as an autonomous test site. Guy Meadows was so gracious to invite me and set that up. Now, when Guy said he was retiring, like, what are we going to do? The Great Lakes Research Center is so fundamental to our institution. And we're very fortunate Tim Davis to take the leadership role of that. Doing an awesome job. So with that, I'll hand it over to you. Have a great day of conversation. Thanks, Devin.
Thank you, President Kovac. So welcome. I'm so excited to welcome you to the GLRC. So the Great Lakes Research Center, this building was finished in 2012 and was built to be a research hub for aquatic sciences, for marine technology, for marine autonomy, the things we're going to talk about today. And as you get a chance to walk around the building, just feel free to ask us questions because we love this building. We love to talk about it. We love to talk about the research that's going on here. So I invite you just to check it out, wander around, look at it. I love working here. It's a really cool place, and we're really glad to have you here. This is going to be a really exciting day. We've been planning this for a long time. We had some hiccups with the pandemic, as we all did, and we were hoping to do this in-person thing much earlier than today. It certainly merits it, but we're so glad that you can come to campus today to spend this time with us. So recently, earlier this year, I got to spend some time with the Director for Unmanned Systems of the Navy, and she heard I was going to be at a conference and requested an audience with me, and I was like, oh wow, like how does she know who I am? And she didn't really know who I was, but she knew what the Smart Ships Coalition was, or she had heard about it from someone and wanted to learn more about it. And it was a great conversation. We talked about cybersecurity of naval vessels. We talked about autonomous naval vessels and research that's going on with everybody in this room, and how that supports the Navy. And then one of the big things that we talked about was, what does this look like into the future? We have autonomous ships everywhere. Autonomous naval ships. We have small boats. We have big ships, and who knows how to regulate this? Nobody's really talking about this. And she said, Tim, I think that y'all with the Smart Ships Coalition are leading the charge on this. I haven't heard of many people talking about this, so she gave me the charge. She said, I want you to work with the Smart Ships Coalition, talk with people, to grow that so that the Smart Ships Coalition can be the leader in determining what are the regulations, what are the coal regs, the standards, certifications, all of that that comes with autonomous vessels, and move that forward, because this needs to be solved. And it would be wonderful if, as the United States, we could have a big part of that. and get this moving forward, because this is going to be a really important problem. We all know, I mean, I'm preaching to the choir here, that almost everything, all our resources at one point, touches the ship, and shipping industry is so vital to the economy of the world. So the things that we're going to talk about today are really, really important, and it's exciting. So thank you again for being here. Let's have a great day. And with that, I'll turn it over to Travis White, who is the lead of the Smart Ships Coalition, to tell us more about what this day is going to hold for us. Thanks.
All right, well, good morning, everybody. I'd like to thank you all for attending and taking the time, making this an event a priority. So we're very excited to see a lot of familiar faces and some new. Some of you have traveled from across the state, but others across the country, and even a few internationally. So we'll get to know each other a little bit better as the day goes on. My name is Travis White. I'm a research engineer here at the Great Lakes Research Center. I have a background in mechanical engineering with an interest in marine technology. I'm a holder of a captain's license, which I use on our research vessels here at the university. And I've always been gravitated towards working around the water. So I spend as much time as I can possibly there, which is why I'm happy to be a part of this event today. In 2018, the state of Michigan, Michigan Tech, and the Great Lakes, St. Lawrence governors and premiers recognized a need to get industry, government, and the workforce developers together to begin hosting some conversations around the topic of marine technology in an effort to advance what we call the blue economy here in the Great Lakes region, but also nationally and beyond. That is the goal of Smart Ships Coalition. And we're very pleased here at Michigan Tech to house the Marine Autonomy Research Site, which is a test bed that the state of Michigan helped us designate, where we encourage the development and testing of experimental autonomy in a sort of semi-controlled environment with a lot of unstructured features. For the past several years, I've been the coordinator of the Smart Ships Coalition, which has allowed me to interface and get to know a lot of your organizations. My goal is to help assemble a very diverse group, very multi-sector, where we can help each other advance our common goals in the maritime industry. Yesterday, many of you had an opportunity to watch some technology demonstrations here at the Great Lakes Research Center, and we had a lot of good conversations surrounding some of the big unanswered questions facing us all. We are seeing a rapid advancement in technology that's happening, and in many ways that's outpacing sort of the governance, regulations, and other discussions, including workforce. And that is really how we're going to set the agenda for today, is to sort of have some of these conversations and identify some of the priorities that we can work on together as a coalition. Our agenda today begins with a keynote from a distinguished guest. Following that, we'll hear from a series of panels representing government, academia, and industry. And all of these people who are in this room today have a common interest in advancing our maritime industry. So my question to all of you today to kind of think about as we get underway is, what can we do as a coalition to enable and advance smarter shipping in the Great Lakes region, nationally and internationally, to make our respective industries safer, smarter, more efficient, and cleaner while growing this blue economy for all? We hope you all feel comfortable getting engaged in the conversation. We have many questions in this room, and we don't all have the answers. So I think we should acknowledge that and be very open with our conversations. Before I begin the rest of the panels and keynote, I'd like to acknowledge the state of Michigan, who's been a great sponsor through the Michigan Great Lakes Protection Fund of the development activities supporting Smart Ships Coalition and helping us to facilitate this event today. So we'll introduce those folks here in a little bit. We'd just like to recognize that they're a big supporter of the work we're doing and making it happen. I'd also like to thank the staff here at the Great Lakes Research Center and Michigan Tech for all of the help pulling this event together. We've in some ways been planning this event for a long time, but in other ways, a lot of it's come together very quickly. Lastly, I'll conclude with some housekeeping notes. We're going to do our best to stick to the times on the agenda that we've shared with you all, and I appreciate everyone's help in helping us keep on track with that. Right now, we are running a little ahead, so I think Captain Koss will have plenty of time for some extra questions and answers if you would like. I'd just like to point out the bathrooms are located out in the hallway next to the elevator shafts. That's the same on all levels. We're going to have a coffee table in the hallway here. We'll have a couple breaks throughout the day where everyone can make sure they've got a full cup. We will be having lunch in the boathouse where many of us were yesterday. So that's all the way to the basement level. And the rest of today's sessions will be taking place in this room or the atrium adjacent to us here. Please feel free to come and go as you need throughout the day. We do have a couple of office spaces on this level reserved if you should need to step out for a business call or something of that nature. Room 204 and 224 just down the hallway. We also have some seating in the back here for folks that do have to come and go, so please feel free. Without further ado, I'd like to introduce today's keynote speaker, whose time and interest in this event is greatly appreciated. Captain Koss joins us today from the U.S. Coast Guard. Captain Koss serves as the Chief of Office and Design Engineering Standards for the Coast Guard's Assistant Commandment for Prevention Policy. His responsibilities include the development of U.S. national maritime safety and security standards for commercial shipping. In this role, he serves as the U.S. Head of Delegation for the International Maritime Organization's Ship Design and Construction Subcommittee, overseeing U.S. initiatives in the development of international standards. I'd like to point out that Captain Koss has spent some time in Michigan. He has his Master's of Science in Naval Architecture and Marine Engineering from the University of Michigan. He's also a 1999 graduate of the U.S. Coast Guard Academy, and he spent some time instructing as well. So with that said, I'd like to welcome you to the front, Captain Koss, and looking forward to your remarks.
Good morning, everyone. Happy to be here. It's a beautiful, beautiful place. And I think that probably, I would say, Travis, this is already successful. Just having this many people together to kind of come and talk about a lot of interesting complexity happening in the maritime environment. And so I'm thrilled to be here. Let me get my notes up real quick. Tim, thanks for having us. I think this research center is just a really, really cool place. The hands-on demos yesterday were great. We've certainly had a lot of interaction with the sea machines, and yesterday watching them come in and do that live demo here just kind of demonstrates where some of this technology is going and the remote connectivity that's kind of been enabled by some of this stuff. And I think that that's really, really interesting. So there is a lot happening. There's a lot happening around the world. I was really impressed last night just at dinner talking about the connections to this area with Finland. And believe it or not, I was with Dorothy when we were over at the Finnish embassy, and they were asking us about the Smart Ships Coalition. And Dorothy and I were both like, we need to find out more about what's going on up there. So I'm thrilled to have the opportunity to come up here and then learned about the great connection that you have. And I think the Finnish delegation just kind of came through here recently, right? And that's really, really neat. So I think that's great. So again, happy to be here. We'll walk through some slides just to try to keep it moving and keep it fresh. One of the things that I think is most important with respect to the scene setter for what I want to do today is a thought got prompted at a recent symposium that we were at that was held by the IMO, the International Maritime Organization. And it essentially was a link to, let's see if this is going to work here. Oh, there we go. So this was presented during one of the speeches, and I thought it was fascinating as a way to like set the stage and think about what we're trying to do with this technology. And essentially, it comes down to the sense that the questions are the same, but the answers are different, right? And so, you know, let that sink in a little bit, right? For the Coast Guard, for us, it's all about safety and security and facilitating the movement of goods and people on the MTS. That question, how do we do that, is still the same. But hopefully today, in some of the discussions that we've had, maybe we can talk about how those answers are changing. You know, what can we do differently based on the technology that's out there? So, sticky keyboard. Well, let's see here. Oh, there we go. Click on the mouse. So, all right. So we'll real quickly walk through a little bit of our headquarters organization, kind of why, you know, my office is here. We'll talk a little bit about my office. We'll talk a little bit about the bigger prevention program in the Coast Guard. How many people are just super familiar with the Coast Guard prevention program and what we do? Good, Frank. Frank, that's a good answer. I like that. I'll call on you for questions then. All right. So we'll walk through that, and then we'll kind of talk about how that leads us into where, where our office is engaged, some of the tech that we're kind of working with, some real life examples, and then we'll get back to those questions that are the same, but maybe now should have some different answers. So that's what I hope to do today. We'll walk through this pretty quick. So as you know, this summer, the Coast Guard recently just celebrated the first female service chief, with Commandant Fagan taking over the helm. So it's a super exciting time for the Coast Guard. We're thrilled that Admiral Fagan actually is a prevention officer. So she comes from our background, and that's really exciting as far as the maritime industry and the energy associated with that. So underneath Admiral Fagan, we have a bunch of our flag officers, and in particular, the Deputy Commandant for Operations, Vice Admiral Gautier, is also a prevention officer. He's actually a chemical engineer. And so he's got the lead over all of us. And then underneath the DCO is the Assistant Commandant for Prevention Policy. That is Admiral Wayne Ardwin. He is also a naval architect from Michigan. So, go blue. I like the tie between the Wolves and the Wolverines. I think that's great. So in prevention policy is this entire prevention program. And then underneath the Admiral Ardwin, we have 3 directors that oversee kind of compliance and verification, that oversee waterways management, essentially the verification and assurance of making the waterway safe for all users. And I think that that's a really important note about all users being able to use the waterway safely. And then we have the Director of Commercial Regulations and Standards. That's my boss, Mr. Jeff Lance. And underneath that is the Office of Design and Engineering Standards. And that's kind of how we're here and connected with you all today. This is my office. It's a team of all engineers, which is amazing. So as an engineer, being as senior as I am in the organization, still getting to work with engineers every day, I think is just fascinating. We have naval architects, mechanical, electrical, chemical, and fire protection engineers. These are our various divisions, and I'll kind of just quickly highlight some of their work with some pictures and slides here. So our naval architecture division, as you can imagine, is that kind of classic bread and butter ship design, but ship designs are changing. We're talking about, let's say self-ballasting ships, or we're talking about wing and ground craft, which is starting to blur the line between a ship and a plane. So there's a lot of stuff happening in the ship design space. There's a lot of questions associated with autonomous tech about, does it change ship design? Should the load line rules change if you don't have people on board? There's a lot of interesting thought kind of in this space. In our systems engineering side, which Commander Strom, Frank is my systems engineering division chief, is a lot of where this work is going on. Alternate fuels, autonomous tech, cyber safety, cyber risk management, which is absolutely connected to what we're going to talk about today. Then we have our life-saving division, which is focused on all of the equipment that goes on board, the fire safety equipment there to protect the passengers and cargo on board, and then all of the life-saving equipment for what happens when things go wrong. So then you think about that world, how does fire protection or life safety systems change as less people are on board? Do you have to up the fire safety to be more automatic? Do you still have to have life-saving systems on board, but does the training have to shift based on who's actually on board? It's really interesting to think about. And then lastly, we have our chemical engineer, our Hazmat division, right? These are the folks that if you want to carry nasty stuff, these are the folks that are driving that charge. We work very closely with PHMSA because, as you can imagine, there's a lot of connection between stuff coming on road, say onto ferries, and then back off-road. So there's a lot of connection that we have with the DOT as far as kind of carrying packaged hazmat and other dangerous goods. And this is the group that is also really closely coordinating on a lot of this alternate fuel work, because they have a lot of tie-ins for how to carry that stuff from a bulk cargo perspective and providing some of that experience into how do we use that perhaps as a future fuel. So it's a little bit about kind of our organization and my office in particular. I want to try to kind of keep this somewhat discussive. I know it's technically a keynote, but I'd much rather talk about things. So are any questions or anything that comes up? Is this a valuable overview? Can I get a head nod and make sure people aren't sleeping? Do we need fresh coffee already? Okay, very, very good. So, all right. So let's then, okay, so we've talked a little bit about my office, then let's talk about this bigger prevention program. And I think this slide is really important. And I heard Travis mention the blue economy, and I think that that's huge, right? So give me a hand. What is the percentage of goods and services that move through our country on water? 97. 97% of our goods and services move on water. So when you talk about the blue economy, you can't be more right, right? We're talking 5.4 going up every day trillion in economic value to our country. We're talking 30 million jobs connected to the marine transportation system just here in the United States. We're talking 360 ports where these things move in and out of every day. And when we talk about autonomous tech, there's a lot going on in that space. The great thing about our country is there is a lot of variability in the various ports and waterways that we have, but there's also a need to try to ensure some type of consistency in that regulatory framework that we're going to work on. So, and then, you know, our program, and we'll talk more about standards, compliance, and assessment here in a minute, which is our concept of operations. But what I want to point out is that our greatest workforce, or I'm sorry, our greatest resource in our program is the people that are in it. And what makes our people so good is the partnerships that we have. And so being here today, I consider a real honor just to start building those partnerships for these types of discussions. So I'm thrilled to be here. So when we talk about standards, we of course have our regulations. We have SOLAS, we have our CFRs, we have a whole bunch of policies. But when you look up on the slides here, there are no standards for these things, or these are the standards that we're working on every day. And that's why I actually really love the job that I'm in right now, is that when we see this new tech, people come to my office and say, hey, we have a new idea. We have a new technology. We want to be able to use it in the MTS. And it's up to my office of engineers to say, okay, well, we want to work with you to try to figure out how we can do this safely. And so our office is kind of always on that cutting edge of technology to figure out what we're going to do to facilitate the use of these things. I think it's really fascinating. So we work on that standard side of the MTS. And then once we kind of get a standard out there, whether it's something that's in regulation or even just policy or even case by case for a particular vessel, we go through the compliance aspect of it, making sure it was built to that Akrinabon standard, doing testing on board to make sure all the systems that have to be integrated for that ship to work are going to work properly. And then when things go wrong, and things do go wrong, because and you guys are probably huge proponents of this, you quite never know what Mother Nature may or may not throw at us. We investigate, we look into it, and we try to figure out what about our system, what about our standards maybe needs to be changed or updated so that we can do it better, right? And so when you think about marine casualties, the root cause for probably over 90% of marine casualties is what? Human error, right? You can get into an argument about the reason being is that's because humans have always been in that maritime space and we're primarily responsible for the operation of these vessels. But it certainly does beg the question, what could we do differently to try to reduce those errors, right? And I think that is what this group is perhaps wrestling with. And I think it's great to have those discussions. So, okay, shifting into the topic at hand here, why we're here. The Coast Guard is working on an overall strategy. So while my office and the Assistant Commandant for Prevention Policy and the Prevention Program is focused on the commercial side of regulations, ensuring safety for commercial vessel operations, we also, of course, have the other side of the Coast Guard, the blue side. And so with that respect, how do we use unmanned systems to improve our missions? Everything from search and rescue to narcotic interdiction to any other type of, to fisheries protection, for instance. How can we use this technology to help us execute our missions? And then, as you think about it, if someone has technology, you have to be able to think about, well, how do you defend against it if someone's going to use it the wrong way? And so there's a group of people that are working on that. The green block here is where we are, right? My office is charged with, hey, how are we going to use this lawfully in the private sector to make sure that that MTS is still safe and perhaps more efficient than it ever has been before. And so that's what we're really going to focus on today is the green block. So this is just a real interesting kind of slide that just talks about the bigger picture of what we're trying to do. And the hub of all of this is data, right? And I think everybody knows that, right? How do we collect it? How do we store it? How do we analyze it? How do we use it? And how do we protect it, right? And then when you think about international shipping, or you think about the connection around the world, is there a common ground where that data can all be used and shared? Because when you think about autonomous tech, how does it stay connected? We're going to need to be connected in order to be able to work back and forth. And so that naturally, with industry and proprietary type of information and technology development, these are one of our bigger challenges to think about, is what is that common ground for connectivity? So how many people are familiar with the International Maritime Organization? Okay, how many people have never heard of the IMO at all? Okay, I think that's good. So the International Maritime Organization is a body underneath the United Nations, and it is charged with developing the standards and requirements for international shipping. So if you think about it, ships sail around the world, and they do so from a common structure, SOLAS, MARPOL, for instance. And what that does is facilitates lawful trade back and forth between all of the countries around the world. If everybody had their own standard, when you pulled into a particular port and a Coast Guard inspector came on your ship and decided to say, keep you from leaving port because you didn't meet a particular set of rules, that would cause problems. It would slow shipping down. So the IMO is charged with, hey, what is that level playing field across the world where we can all agree on a standard that all of the ships sailing internationally can adhere to? So it's pretty powerful. There's a lot of committees that meet. We have technical committees, we have legal committees, and we have facilitation committees. Technical and legal probably makes sense. Facilitation, I even had to ask myself, what is that? That's all about the interface of when a ship comes into port. When it comes in, when it unloads, when it stays, when it leaves. What is that standard by which seafarers can say, get off the ship and maybe run to Walmart and get supplies, for instance? Can we do that in a safe, effective way for all seafarers around the world? So that's what those kind of three big committees are focused on. As it pertains to MASS, Maritime Autonomous Surface Ships, which is kind of that international word that we're using right now, all three of these committees have recognized the importance of looking at our existing regulatory frameworks and then conducting a scoping exercise, going through SOLAS, going through MARPOL, going through COLREGs, and finding out what are the gaps, what are the barriers to being able to use this technology. And so all three committees have completed those scoping exercises, and all of this is publicly available through the IMO's website. But we've identified several common gaps and themes that we all need to work on, and we have begun that work. So on the MSC side, which is the Maritime Safety Committee, that's the technical group. And as of this past April, we were charged with beginning the work on the development of a non-mandatory code for maritime autonomous surface ships. So we are now starting to meet as a worldwide group to start looking at what does that code look like, what needs to be in that code, and then what are going to be the goals and functions that go into that code. So again, this type of meeting today is hugely relevant for kind of that worldwide effort that we're trying to take on with this. So similarly, we just met as a joint working group. So it is rare, but it happens from time to time. And again, I think that just highlights the significance of this, where all three committees have acknowledged the importance of this work across the board to say, we need to get everybody together. We've got to put the engineers and the lawyers and the folks that are looking at that port ship interface on the FAL side. We need to put everybody together and try to make sure that we're looking at this the same way, because we're going to have to update our rules. We're going to have to update our regulations. And so we need to understand that common picture as we move forward. And so we just met at the beginning of September as for the first time as a group to start going over the issue. And some of the questions will come up today are some of the questions that are coming right out of that conversation. So I think that, again, this is really, really great time and I'm super excited to be here. These are some of the common areas, and we'll get more into this in a minute, but just wanted to give you, like, if you had to pick a couple things to really focus on, these are the types of things we're really driving at right now. What's the role and meaning of the master and the crew? What is this idea of remote operator or the control station? We'll have more questions on that. And then again, we talked a little bit about connectivity, but protecting that data is important too. So that cybersecurity perspective. There was some great conversation yesterday during the demo, and the line of sight and the RF constantly switching frequencies with respect to you guys piloting the jet ski. And I think that that's some of those great questions that are happening. And then what is that common terminology that we can all agree on? Because if you don't have that common understanding of what a particular word means or a particular term means, it can really cause some grief, particularly as ships start moving around the world with this type of technology. In the United States, we are also kind of focusing on, hey, what is the domestic landscape regulatory framework for this type of technology going to look like? So our Commandant, Admiral Arwin and Admiral Mauger before him kind of said, hey, I need a policy group. This is way bigger than one office. And you can see these are all the offices here that are part of this policy council. And I want you guys to consider this space and what is the type of policy guidance that we need to start putting out to help people understand how they can use this, how the Coast Guard is looking at that space. So you can see some of our objectives up here. You can see our organization, right? And again, it is a really interesting discussion about where our world typically lies, which is in commercial big ships. Solus, of course, is 500 gross tons and above is kind of where you're getting started. But because this technology is so new, we're also kind of coming into what about some of the smaller stuff that's happening? What about some of these smaller ships like Sail Drone, you know, or other oceanographic research vessels that are much smaller? Are they still a vessel? Are they equipment? What are we going to do about that? So this group's kind of looking at those types of questions too, and they're fascinating questions. So that's kind of what's happening. Just some examples of the lines of effort that we're working through, similar to what we did for Solus. We're looking at our US laws and our US regulations, and we've kind of gapped out what are some of those challenges, right? I mean, who's tracking on Colregs Rule 5? What's Colregs Rule 5? Where's my mariners? Frank, you're not allowed to answer. Everybody knows about the lookout issue, right? So collision regulations require by sight and sound detection of hazards to avoid collision. Sight and sound in our country is meant to mean a human. That's something we have to work through. I mean, that is the current legal practice for a lookout. And so those are things we have to think about and address and change the answers to if we're going to keep moving forward with this. Manning and credentialing, right? I mean, the Maritime is all about the Seafarer, as it should be. So we're working very closely with our mariners. We have a federal advisory committee called NMARPAC. It's the Merchant Mariner Advisory Committee. And we're working with them to kind of pose some of these questions to them, to ask them about, hey, as this technology is developing, what are those functions that you would say you do on board a ship that maybe could be replicated or supported or advanced by technology? And so again, part of getting people together and talking is trying to find that common ground for all parties, especially in the maritime space. So we have technology, we have the seafarer, we have the ship owners. How do we get everybody together to be talking and finding that common operating picture? And then naturally, risk assessment and acceptance. I think the acceptance piece is really, really interesting, right? I was talking with Travis, and I think anybody that has sailed or been on a ship, there's no way to avoid all risks until you put it back on the trailer. And then it's questionable if the tires on your trailer actually have enough air in them. But the safest ship is a ship on land. That doesn't do us any good for what we need to do. So in this new space, what is that acceptable level of risk that we are all willing to tolerate as a country, as a world, as this keeps moving forward? That is really interesting. Some would say that the technology will actually make things safer. Okay, but I don't think we can completely get rid of all the risk. So what is that level that we're going to be willing to accept as we keep moving forward? And then based on kind of those lines of effort, we're working on some different compliance tools that will hopefully provide some guidance to the field. And again, this is very, very nascent. You know, we're still working through this, but just some examples of some policies that we have out right now. We have you know, if you're looking at doing something novel in the marine environment, we have some guidance out there, and we'd be encouraging you to talk with your local Coast Guard field personnel to kind of talk about, hey, what are you doing? What's your plan? Making sure it's done kind of from that risk assessment perspective, and then documenting and collecting the information on what you're doing, because that's starting to feed that bigger picture. And then the other policy letter that was put out was this acknowledgement that, hey, we know this technology is going on. We know it's out there. We want to encourage its use, and we want to be able to talk to you about it to try to keep gathering that data, but recognize we've got to still do it under human supervision right now. We still have to follow our classic manning laws and regulations until we are able to change the answers to the questions that are currently out there. So let's do that testing. Let's gather that data. Let's prove that this is viable and feed that information up to help build out that regulatory landscape. All right, getting into some of the good stuff. Space operations. Why do space operations need to deal with autonomous type of vessels? Comms, okay. But I mean, I can have people on board and still talk to a vessel all the time. What else?
SpaceX barge.
Yeah, but right. So why does that need to be unmanned? This is fascinating if you put it in that perspective. Safety, but give me more. Absolutely, give me more. Why? Reliability, right? So what is the barge? What is the SpaceX barge actually out there for? To catch the rocket coming in from outer space. Folks, let's talk about cool technology, right? They're landing a rocket from outer space on a 300-foot piece of steel. I don't know. I mean, that is fascinating. It is amazing. Part of the way they figured that out was they figured out how to actually compress the oxygen a little bit more to get about 8% extra capacity. That 8% is how they're able to bring it back, right? Like when you talk about margins and technology, it is mind-blowing, right? However, it's probably hot when that rocket's coming down. And so we probably, right, shouldn't have humans out on that barge when that rocket's coming down. And so in this particular case, are they in compliance with our laws? No, they're not. But this is where, when you talk about risk, it's not just about the legal risk, right? We also have to account for that safety risk. We also have to account for political risk, right? We've been told by the White House, and I think we can all agree, that space right now is a national security priority, right? So how do we make that work? How do we manage that? So we are working very closely with SpaceX, and there's a couple other companies. Blue Origin is looking to get into the game. The Spaceport company is looking at doing something slightly different, but working with them to try to figure out how we can manage this risk, taking into account the risk to human life, and also kind of the account to those risks of, hey, we still need to be able to do this safely. So space operations is really kind of leading in this space because of that danger to human life. Yeah.
Can I ask you to give right now for those and for me, just a brief summary of what the regulations are or how they apply to unmanned ships?
There are no regulations for unmanned ships. So the starting space is, especially, and again, you know, I'm thinking commercial, right? Like my bias is commercial ships, those that are carrying cargo or people. So that bias is, you start with a manned vessel. And so do I have any kind of towing vessel operators here, or anybody that works with towing vessel companies? So we have a challenge when we implemented the new towing vessel regulations that the rules have always been there for having a certain number of people on board. But as a result of some change to some regulations, there were some questions that came up about, do we have the right number of people on board? We've been doing it a different way for a long, long time. What do we do now, right? So there are no rules for unmanned ships. The rules say you have to have people on board. However, that's why I think we're all here, is we're learning that this technology maybe needs to change that answer. All right, keep moving here. I know I'm running a little long, Travis. So
You're doing great.
the Mayflower, who's familiar with this project? Who has no idea what this is? Someone give me, okay, this is cool, right? So a couple of years ago, a bunch of people got together and said, hey, the 400th anniversary of the Mayflower is coming up. We should do something. And they got together with some of the, bigger folks, and I can't remember the actual names of the folks that built this, but they said, yeah, we don't want to build another tall masted sailing ship. We want to represent what the next 400 years are looking like. So they got together with General Dynamics and IBM and said, let's make an autonomous ship to sail across the same path. Well, even though it was autonomous, they didn't realize that COVID would still impact them. So they had a bit of a delay in getting this thing off the ground. And then as luck would have it, in 2021, they started the voyage and it broke down. And so they had to go out and get it, pull it back and do some more testing. They tried it again this summer and they had a couple breakdowns, but they made it all the way across. And really, really cool. You can see the kind of size of it, perspective for a human there. It's just about 45 feet long. In compliance with the coal regs? Absolutely not. A real challenge for us as Coast Guard regulators, because this was a US flag vessel. The UK said, yeah, we're not going to flag this. So we said, oh, we'll flag it. It gave us a lot of challenge, especially from a legal perspective. They were not in compliance with the laws that we are all supposed to abide by as they came across. However, there was multiple decisions made by senior leaders in the Coast Guard with respect to, hey, we're going to have to be willing to accept this risk. We're going to have to work with the owner operators. And what is that risk? Who's going to actually board this thing out in the middle of the ocean and detain them on the high seas for not having people on board? Those are some of the questions we had to ask ourselves. Is it a risk that we can accept? Now, once they got over to the United States, the district commanders provided them a whole bunch of operational controls that said, hey, when you get inside 12 miles, guess what? You need an escort vessel that can immediately get control of this thing. Because the first thing was, we want a person on board. And they're like, yeah, have you seen this thing? Where are we going to put a person? Right? Standing on top of the saddle there with the reins. What do you want me to do here? So, okay, fine. Let's come up with another option. Let's get a sea tow vessel right behind it, that if you had to get a person on board to hit the kill switch or whatever, you could, right? So we worked through it and it went pretty well. So this is a really great project. We just had somebody from District 1, which is over in the Northeast, come down to headquarters and actually kind of go through some of the collision avoidance scenarios that they had out at sea. And believe it or not, in the 3 cases that we hot washed, the first case was the traditional vessel that was involved in the encounter didn't follow the rules of the road properly. Okay, that happens. The second case, the vessel didn't quite understand the situation well enough, and so it proposed a solution that wasn't quite right. And in the third case, the remote control operator was like, oh, I see what I need to do here, and they went the wrong way. So, we're still learning and we're still growing, but it was fascinating to kind of gather that data and be able to hot wash the technology and what it offered and what we need to do with that going forward. So this is a really, really neat project. How about some of our deep draft companies out there that are using what I would call really sophisticated autopilots? Is anybody familiar with the American Courage? A little bit. So as we've been asking these questions and bringing that group together, we found out that through Wardzilla, they installed the semi-autonomous system and they've been running the Cuyahoga River. Who's been on the Cuyahoga? Windy? Very windy. I think there's some bridges too that they have to go under, right? So for the past couple of years, fully manned, and I think this is where we want to be, fully manned, but they've been using that semi-autonomous system to go dock to dock. And they've been doing it pretty successfully. And I think it's fascinating. I have not actually had a chance to get on board these or actually talk with, let's say, is this Interleague or is this Great Lakes Steam? American Steamship, thanks. I haven't had a chance to chat with them yet, but Wardzilla came and talked to us about the technology they're using. It's the same technology that's actually on the SpaceX barges and some of the technology that's being used over in the Scandinavian countries. So really, really neat. How about the LNG tanker Prism Courage? Does that ring a bell for anybody? it rang a bell for us on a Monday morning when the Maritime Executive, which is a common newspaper article, put up a thing that this boat had sailed from the US autonomously back over to Korea. And my admiral immediately asked me to pop on by and explain to him what the heck was going on. I don't know, sir, it's a foreign flag ship. They don't have to get our permission for anything. So turns out, but sir, I will look into it, you bet. So turns out that they came into Texas and they loaded LNG, and they have on Korea's latest it's HINAS, their kind of high navigation autonomous system 2.0 version, and they wanted to test it. So they're fully manned, which is okay, right? They're fully in compliance with the rules, but they went through they left the United States, went through the Panama Canal, and when they got on the other side of the Panama Canal, they engaged the system and it sailed all the way to Korea on that new system. And so they're starting to test that system and they're very pleased with the results. And so, we are starting to see this on some of the deeper draft ships. And the really, really neat thing that you can think about when it comes down to some of this autonomous navigation is they saw about, I want to say it was around a 5 to 8% increase in fuel efficiency because of the steaming that was straight line, didn't have to make adjustments or was able to plan far enough ahead, and just a lot less stress on the crew as far as, they could kind of be there, but not necessarily completely focused the entire time. So it was really, really interesting listening to Korea talk about, what this technology is looking like as they continue forward with it. So I thought that was pretty neat. A couple quick more here. So we're starting to see, as we're looking to ramp up the development of offshore wind in this country, a real need to be able to get some seismic surveys of the ground floor in order to figure out where to put these offshore installations. And so there is a lot of interest in beginning use in, hey, how do we do this work? How do we quickly map out this seafloor so we can try to meet those administration's goals to get this offshore wind going in the country? So again, significant national interest. How do we work with them to get through this? Here's a real interesting question for all of us. Is this a vessel or is this equipment? Legally, we have to answer that question. And I'm not sure right now, but those are some of the types of questions that we have to be thinking about. And then there's a lot of work going on in the international space. These are just some of the various examples of ships that we've had conversations with folks with. The American Bureau of Shipping, which is our class society here in America, has some guidelines and notation for autonomy, and they've actually been starting to give notations to some tugs over in Singapore that they've been working very closely with. And the folks over in Finland are using that Wardzilla system, and they have been having incredible kind of point A to B to C runs with their ferries using this technology. Again, they're fully manned, but the technology is essentially doing the dock to dock autonomously, and it's going really well. Same thing, a little bit of improved fuel efficiency, more consistent dock to dock times because the weather doesn't impact them quite as much. And so it's been really fascinating what they've been learning about this. So, okay, let's get back to those questions. I think, and I apologize, this is really small, but these are the types of things that I think are worth thinking about as we talk today, right? These are exactly what the joint working group is starting to wrestle with around the world. So the folks that are engaged at the IMO are starting to ask these same questions, and we have to start saying, how are the answers changing? So is the master and crew still a seafarer? Is the master still ultimately responsible, right? Like I'm a very much a traditionalist. I do love technology, but I also love pictures like this. I was going to be the captain of Eagle one day, which is our, America's tall ship. When the ship left port decades ago, even still today, that ship captain was ultimately responsible for everything that happened on that system, right? The ship is an ecosystem. It's out there. That captain is ultimately responsible. As soon as you start putting in remote control systems or other things to shoreside, can we say that that captain is still truly able to manage everything on that ship when it's being controlled shoreside? That's a really interesting question. If you were to ask the ship captains now whether they already have enough on their plate, I think we all know what that answer might be. So what do we do with that? The same thing kind of goes for the crew. as far as kind of in those classic, master or engineer type of licenses, what does that world change to now? What are their responsibilities? And then how does that change into what are the requirements for safe manning or safe watchkeeping? And so then if the operators are shifting shoreside, well, what now are the roles and responsibilities of those operators? And what happens if, let's say it's a US vessel, but it's being remote controlled from Finland? Is that remote control station under the jurisdiction of the flag state of the vessel, the state that's responsible for certificating that vessel to sail? Or does it belong to the country where it's posted? That's a really interesting question. How do I do steering tests from the remote control station in Finland? I mean, I'll take a trip over there and, be the guy talking on the radio to the guy on the ship to say, hey, let's do this steering test to make sure it's working, right? But we're gonna have to start thinking about that. Even here in the United States, what if we have the control station in California, but the ship's on the East Coast? Do I have to have a Coast Guard officer over there in California at the same time I'm doing my inspection on the ship over in Boston, if you will? It's really, really interesting. And then kind of comes down to that remote control center and station. What are those requirements? Is it part of the ship? Who's got the jurisdictional responsibility? How many ships can they be responsible for? Really, really interesting questions. And then sometimes we don't even think about the questions that other people are thinking about. Is the remote control operator the lookout operator and master at the same time? Because on a ship, you kind of have at least two, sometimes three, depending on the weather conditions. But right now, we've had some conversations where we say, who's in charge? And they're like, oh, the remote control operator. Cool. What's his seafarer knowledge? He's just the Wardzilla tech that designed the system. He can drive it better than anybody else. Okay, that doesn't necessarily compute with the current, answers we have to the questions that we typically ask. So who's the master in charge of this vessel right now while it's out there? So a lot of good questions there. Some more stuff in the legal realm. Who knows when I say UNCLOS? Anybody know what that is? Right, so this is the United Nations law of the sea. That's that common legal realm by which ships around the world kind of sail. If you had 10 lawyers, you would probably get 9.5 opinions that are different about the law of the sea and whether or not it can we can use this technology underneath that existing umbrella. There are those that believe, yes, it's flexible enough, but everybody acknowledges that the law of the sea was designed with humans on board. So what do you do with that? How do you work through that? It's a really, really interesting legal question. What's that? And we, the United States, is not signatory. So we are able to have great conversations over there, but that's about it. So that is part of the fun job of IMO, is there are things we're not signatory to and we still try to get our punches in. So we talked about Colregs Rule 5, sight and sound. We talked about watchkeeping and manning. Those are legal boundary conditions right now that we have to be thinking about. And then when we get into that operational realm, how do we still ensure safe navigation? Are there areas where maybe we're willing to allow this technology, but maybe there's some areas where we're not quite yet? And how does that happen? And then what like we talked about before, what are the risks are acceptable? And do the risk profiles change if this technology does enable us to be able to look at that? There's one more slide for you. And this is, I think, perhaps for the group. I tried to keep this one for last, looking at some of the kind of technology realm questions, right? So with respect to system awareness, do we have the capability to monitor all of those vital systems and be able to report if there's going to be a problem? How do we make those notifications to whoever is in control, or even if it is AI, does it know that there's a problem? Can we maintain all of the various pieces of data that are being fed in and have timely ways to report if an incident happens? System safety. We have system safety requirements right now for traditional ships. We would expect at a minimum that any system being designed would at least meet or perhaps exceed those existing requirements. So do we fully understand what those requirements are as we're working through the technology development? We talked about redundancy. I asked that question a little bit, later or earlier. When we're working with dynamic position systems for oil rigs down in the Gulf or whatnot, it is critically important that no single failure causes something to lose control or go off station. So do we have that, right? So if like you have a computer on board that is doing all the data and making all the identifications of objects and so on and so forth, guarding that waypoint, can you have just one computer? Is that acceptable? I wouldn't think so. I wouldn't think so, right? But that's what we have to be asking ourselves. What is that acceptable level of redundancy? The Mayflower actually lost their main computer when they were transiting. They had a backup computer, but even so, they pulled her in to make sure they could get the second one, figure out what was wrong with the main computer, get it back up and running. And then, of course, safety of navigation. Does it actually move in a predictable and reliable manner when it's interacting with other traditional ships, right? If it presents as a ship, does it actually act like a ship, right? That's really interesting when you're thinking about that interaction with the other space. And then just lastly, that idea of, we need to be able to design whatever these things are so that we don't impact the safety of the marine transportation system, right? That is our nation's livelihood. And at the end of the day, that is that essential question, right? How do we protect the MTS so they can keep serving us as that blue economy that Travis said so well? So I think that does it for me. Oh, I went the wrong way, sorry. And then just kind of wrapping up here with that slide, right? What we're really looking for is these discussions, having these conversations and trying to ensure a consistent way ahead. We don't have all the answers, but I think it's really important, and I can't stress this enough again, that we also have to be willing to look for new answers. So I think I'll stop there. Like I said, I apologize, I talked a little bit long, but I think hopefully this was valuable to you guys to kind of set the stage. And I really look forward to a lot of the discussions that are going to happen as far as, hey, what could some of these new answers be? So that's all I got.
Thank you very much, Captain.
Do we have time?
I think we have time for one or two questions, and then if you'd like to defer those to the panel, we can do that as well. Your preference.
Yeah, I mean, I could take a question or two if there's out there. Yes, sir.
Are the P&I clubs part of your discussions in the autonomous vessels?
So yes, through kind of the broader IMO conversation, there are representation from the P&I clubs, but it's always measured. It's always measured with respect to the things that they're looking at versus, kind of what we're looking at from a regulatory perspective. So
In my opinion, I think that's a very important element. Even if the vessel thinks it's doing all the best things in the whole world, if in fact say any other commercial vessel, you have the same problem.
absolutely. So absolutely, sir. And I think that that is where we kind of get into a lot of the stuff that is kind of driving alternate fuel or even this technology is this idea of market-based measures, right? And so the insurers fall into that, right? I mean, at the end of the day, SpaceX can do what it does because it's self-insured.
Correct.
But most traditional ships require a different type of insurance and multiple types of insurance. And are the insurers going to be willing to accept the risk from the way that they look at it? It's well said. Other questions, comments? Yeah.
A lot of bridges to cross before we might get here, but I'm curious if there's any initial thought to physical security. So let's say we do reach a time where an uncrewed vessel is flagged and therefore, a U.S. ship and it was intercepted by whoever it may be. What would elicit and would it elicit an armed forces response like a manned ship would?
So I'm definitely not ready to get into the armed forces response, but it is a great question. Physical security requirements exist for vessels now, particularly those that are carrying many passengers or significantly dangerous cargo. And so we have had some really, really good questions with SpaceX about that, right? So let's say that, because right now, with respect to this type of technology, the proprietary aspects of these systems are really important. And so trying to protect that data, right? So if you're a unmanned ship out there on the high seas and there's nobody on board and a nefarious actor wants to get on board that vessel and try to take that tech, what's to stop you? So we joked a little bit with SpaceX and just trying to keep it light here about the idea like, well, if there's nobody on board, why don't you just elect to fly the boat? right? And then if someone does try to come on board, they won't get very far, right? I don't know that we could really do that, but I mean, those are the types of things that, you know, we're gonna have to think about. So absolutely, good question. Yes, sir.
This is probably way too basic of a question for you, but the Great Lakes are considered international waters?
No, absolutely not. So, and then this is a really, really good question with all kinds of other regulations that we're working on right now. But if you look in SOLAS, when it defines the maritime environment, it does not include the waters of an individual nation. And so in this particular case, the Great Lakes, even though we have a joint neighbor with Canada, it is not connected to the high seas. And so the international rules do not apply here. We have our US rules for the Great Lakes, and then we have our bilats with our Canadian counterparts for operation on the Great Lakes. So great question. Do one more. Yes, sir.
How is the FAA implementing some of the strategies that they've used into these discussions?
So we have interagency connections, FAA, DOT, MARAD, you know, NASA, right, is a big part in the space world. So we have lots of conversations, but it comes down to who has the authority for the various different areas, right? So we can leverage FAA expertise as we build out our framework, but the FAA does not regulate the maritime environment. So I think that's where these types of conversations, where our interagency partnerships, and so when the Coast Guard goes to IMO, we don't just go as the Coast Guard. We take mariners, we take seafarers with us, we take the American Bureau of Shipping Technology reps with us, we bring the Department of State with us, we bring, depending on the topic, we'll bring other interagency partners with us that kind of help inform those conversations. So good question. Okay, Travis, over to you.
Thanks so much,
Here all day, folks.
So next, we're going to have a panel where we can hear some additional government perspectives, and we'll invite Captain Koss back to join us for that. I'd also like to invite up Mr. Howard Poslums from Transport Canada, Miss Emily Fennell from the Office of the Great Lakes, and Mr. John Smith from the Great Lakes St. Lawrence Governors Premiers. And to start with, I'll have everybody take a seat up front, give you all a few minutes to introduce yourselves and your organization. And I would sort of like to just begin with, in your introductions, asking you all, why is smart shipping, maritime autonomy or technology important to your organizations, and how is your organization working towards the advancement of these things?
Well, good morning, everybody. It's great to see all of you here today, and welcome to Michigan from our great state, and welcome to the campus. I'm Emily Fennell. I am the head of the Office of Great Lakes Senior Advisement Strategist. Our office is created in statute back in 1985 to lead policy and program development to help protect, restore, and sustain the Great Lakes watershed. So we work quite a bit with our binational and other Great Lakes state partners. We also work very collaboratively with a lot of different partners, including our academic partners, business, industry, communities across the state of Michigan to help drive those long-term policies forward. One of the core program areas that we focus on through our office is around sustainable Great Lakes Maritime. So Smart Ships Coalition is one of the initiatives that we've been intimately involved with since the beginning. We're one of the original sponsors, but we've also been providing some funding through the Michigan Great Lakes Protection Fund that our office administers. So that's part of the reason we were able to have today's in-person. For the state of Michigan, I'll speak on behalf of the agency that our office house, the Department of Environmental Energy, and a number of our other state partners. We see a lot of connection in the work that the Smart Shipping Coalition is doing around advancing autonomous technologies and other marine technologies, and tying into not only our goals for sustainably managing our Great Lakes resources, but also helping drive forward our climate, energy, sustainability goals in the state, and tying in connections with some of our new offices around the Office of Sustainability and Work. So there's lots of intersections across many of our state agencies And we have actually, through our office, been convening a Michigan work group involving those agencies and programs in support of Michigan Tech, kind of a sub work group under the Smart Ships Coalition, really helping to identify opportunities where we can collaborate more, help support the ULRC in this work and providing leadership on the Smart Ships Coalition, and then advance a number of our Michigan priorities. So we've been meeting, I think, almost for a year and a half, 2 years on a regular basis, and it's been a great forum for sharing information and collaboration. Another area that we're focused on through our office is around the water STEM workforce development, career preparation, planning for kind of building that next generation of water stewards, leaders, decision makers. And I just want to recognize Travis and Tim for their leadership on the Smart Ships Coalition, their work at the GLRC, and the great work that they're doing here to help accomplish a lot of the goals that we're all working on together. So thanks for having me.
Thank you.
So I guess it's over to me. Good morning, everybody. My name is John Schmidt, and I'm the Maritime Program Manager for the Great Lakes St. Lawrence Governors and Premiers, or just GSG. It's a little kind of a mouthful. For those of you who maybe aren't familiar with our organization, we act as kind of a bi-national policy organization, and our board are the 8 Great Lakes state governors and then the premiers of Ontario and Quebec. We kind of have a dual mandate. One of them is supporting economic development here in the region, and then the other is protecting this world's largest source of fresh water. So those things are often not in harmony throughout history. You think of kind of the old model, which is just use our natural resources, deplete them, spend a ton of money to try to fix them if you can, and then repeat the cycle over again. So we're trying to get away from that and have economic development will be respectful of these waters. Our work spans really a broad range of activities. We have an impact investing platform that connects folks around the country and around the world with green projects here in the Great Lakes. We have some trade offices. We worked on water use between the US and Canada over the years. And then, as I mentioned, I'm the Maritime Program Manager. So my work revolves around electrification and biofuels, smart shipping, of course, which is why I'm here today, and a whole host of other things in the maritime sector. So GSGP was one of the founding members of the Smart Ships Coalition, and happy to be joined by all other founding members here today and see such a big audience. Yeah, as an organization, and I know this is maybe the next question, but why it's important to us, it is very, very important to us, and it's something we think about in pretty much all the maritime conversations we have. So.
I used all my time. Good morning, everyone. Thank you. Could I take your time? Yeah, please. So my name is Howard Paulsons. I work for Transport Canada, the Innovation Center, which is the R&R of Transport Canada. Canada is much smaller than the US. We are multimodal. So what that means is that we do projects not only in autonomous shipping, but I work on autonomous cars, drones, satellite technology, and everything else they want to throw in. So the advantage of that is I get to see something that's in the aviation mode and say, oh, maybe we can use that in we're talking about SpaceX, etc. So I work on a lot of drone projects that are moving over the water. Anyway, it's interesting. So many years ago, probably 2018, Transport Canada got interested and involved in the Smart Ship Coalition, one of the original founders of the Smart Ship Coalition. And the person who was running that, Donald Roussel, he was the brainchild of you should have autonomous ships in Canada, or we should be supporting them. So I went to speak to him often because I was working on autonomous cars, etc. And unfortunately, Donald Roussel retired. And Transport Canada said, okay, what are we going to do with this program? No, I'm not just going to throw it away. I know, we'll give it to the Innovation Center because it's innovative. So they went over to the Innovation Center. My director general says, yeah, we'll do it. And then the next day, I get this phone call, Howard, how would you like to run this program? So it was thrown in my lap. I said, yeah, no problem. I'll take it. I had already been speaking to Donald, so I knew about it already. And so we came up with the Canadian Forum for Marine Autonomous Surface Ships, CFMAS. And that's what we have now. So what do we do under the Canadian Forum for Marine Autonomous Ships? We do several things. We run seminars during COVID. So this came all about this sort of during COVID. So during COVID, we ran these seminars roughly once every month, once every 2 months, and inviting presentations from all around the world, including Travis and many companies that may be in this room, to give Canada an appreciation of what is mass, what will it do for you, what not do for you, and how shall we take care of it in Canada. So I'm working closely with our National Research Council to enable mass for Canadian waters. By the way, I do these presentations all the time. The last one was about 2 months ago in Halifax, H2O. I was looking at the presentation yesterday. I said, well, I'm not going to put it up on the screen. I'm going to use some notes. These are notes that I made for the presentation. So you're getting the Cole's notes, concise version of the presentation. So we give seminars, and maybe some of you have attended. By the way, they're open to anybody can attend. We provide R&D funding to Canadian universities, to small enterprises, small companies in Canada, and academia. For example, we are very concerned with cyber. Everyone else is, and we have presentation from Memorial University of Newfoundland on all of cyber. There's a researcher there that has really worked for us on that. And hopefully in the future, maybe we'll be able to participate in Travis's cyber challenge on ships. I'm aware of the cyber challenges. As I said, I do connected vehicles. So there's already a truck cyber challenge. It's run by somebody else. So very similar. You have students that try and hack into cars or ships. And so, and the industry works closely with them because the industry wants to know where are the weaknesses in their system. The Memorial University, based in Newfoundland, actually has just purchased an autonomous ship. It should be getting it any day now. It's actually a Sea Robotics ship that comes out of Florida. It's an 8-meter ship. And we contacted them and we said, you know, we should be working together to do something. I'm not sure exactly what, but when I say we, I'm talking about the National Research Council with money coming from transport. So we're trying to more and more get universities working on autonomous ships. On the West Coast, we have the University of British Columbia that has an autonomous sailboat. So slowly and surely, in Quebec also, Public Technique, University of Montreal is also working on some ships. Slowly and surely, we're trying to get the best talent STEM for working on autonomous ships. It doesn't exist now. Actually, in the UK, I think they have a program that's trying to develop the talent needed for this future technology. So, do we manufacture autonomous ships in Canada? Yes, we do. On the West Coast, we have a small company called Open Ocean Robotics. That is a small ship. It's roughly 12 feet long, 3.5 meters, 165 pounds. It's used mostly for environmental monitoring of the ocean, measuring temperature, salinity in it. We've used it recently to listen for underwater sounds. We're trying to save the whales. There are not that many whales still around. So we tow a hydrophone back on the ship. It's an electric ship, so it doesn't make any sounds, not disturb the whales. And once we find where the whales are, we actually give a notice to mariner of one. Say, please don't go in. Please don't go in this area because there are whales there, and we don't want you to hit the whales or the whales. You trying to save the whales. So we're doing that both on the West Coast of Canada and on the East Coast of Canada. On the East Coast, we're using more than autonomous ships. We're using underwater gliders, open gliders, like you see downstairs, working with the University of New Brunswick on that. But again, to listen for the whales, we're also using drones, fly over a specific area to look for drones, and we're using satellite technology. So obviously, whales, sailing with whales is important in Canada and in the US, but the US, multiple US partners as well. NOAA, et cetera, down in Boston, but we're working with all of them to save it. So an autonomous ship is a great platform to put out there because it's quiet to listen for the whales. On the East Coast, we have a company, you saw a picture of X-Ocean, which is an Irish company that basically set up shop in Halifax. And they are manufacturing larger autonomous ships. Theirs is roughly 15 feet and it's 1,700 pounds. It's a larger autonomous ship. The main use today is bathymetric surveys. Our Department of Fisheries and Oceans are using them to do bathymetric surveys in the Great Lakes. They're already being used right now. So our industry is really small. There are some up and coming companies, a company called HydroServe, which is from the UK. They're offering mast as a service. Want to hire them to do a bathymetric survey, et cetera. They're doing that. And a lot of autonomous ships are setting up in the east coast of Canada, the Halifax area. And the main reason is we have this large funding source that's called the Ocean Super Trust that gets money from another government. These companies, a lot of them British, basically come over, set up shop, and set up on the ship platforms. Again, our goal overall is to set the stage, make it easier to run an autonomous ship in Canada. No, we do not have any regulations in Canada, just as in the US. We do recognize autonomous ships, so we came up with a policy for small autonomous ships. It's on the internet. You can actually go just put in small autonomous ship transport Canada policy. It's roughly from 2 to 12 meters, and it's less than 15 gross. Yes, less than 15 gross tons. So that's the type of autonomous ship we're targeting. We don't have anything with a larger ones. So we're getting Great Lakes, very important, shared between Canada and the US. We have a Canadian company, Algoma Central, and they have put some automation on one of their lakers. They're using a company called Buffalo Automation that actually has automation, and they have been testing using not full autonomous mode, but they're starting to put these technologies on, similar to the American Courage. As you were giving your presentation, I said, yes, we have that, or no, we don't have that. So I was doing the comparisons, what we're doing in Canada and what we're doing in the US. So we do recognize autonomous ships in Canada, but with no regulations, we have policy. By the way, I'm the innovator or the R&D person. I'm not the regulator, but what I do is I provide the scientific data so that when our regulator, or NARAD, I guess, decides to develop a regulation, it makes sense. Because we can't have a regulation that makes no sense, the industry will kill you. So you have to provide all of that smart data. That's what I do by doing these tests. Speaking of the Mayflower, exactly what Captain Cost said, it actually arrived in Canada because it had a problem, and it says, we're not going to get it. We're planning to go to the US, down in the Boston area. He said, well, we don't think we're going to make it. We better land at the ship. The closest distance that happened to be Halifax. It happened to be during this H2O conference. So we were very fortunate to have it land. I was speaking to all the technicians, speaking to all of the people there. They said, you know how maybe we'll do some work between Canada and the US Mayflower and use it as a scientific platform. So we can do that. So I was fortunate to not go aboard because there's no room really for people. If you look inside, you know, you have the headspace about that and all those computers. But I got to speak to the technicians, and that is the most advanced autonomous ship in the world. It's quite amazing. I did make it from the UK all the way over to North America. So it's pretty good, the most advanced. So it's obviously it's a test platform, a trial platform, but that's good. So why do we want to talk to ships in Canada? What can we use them? Thank you for using your minutes, but I appreciate it. We can use it for autonomous barges. The Port of Halifax came to us and said, you know, instead of moving cargo containers within the port on a train or a truck, why don't we put it on a barge? Okay, that's an interesting idea. So this would be an autonomous barge. You put the cargo containers on a barge and autonomous, and it goes from point A to point B within the terminal, within the port. We have fish farms in Canada, and these are pens where the fishermen, you have to feed these fish. So you can put a fish feeder, a autonomous fish feeder, you just run it out to the cage, just in the water, just drop the food. That's another interesting idea. In the north, which is interesting, in the north, we have these ships that come in up in Churchill and Callaway, and they don't really dock. But there may not be a dock up in the north. So we can send a autonomous barge that actually goes to the ship, and then you have the loader that takes cargo, also on this autonomous barge comes. So we're thinking of all of these ideas. Where can we use an autonomous ship? The marine mammals I mentioned to you, basically putting hydrophones to listen to the mammals. Autonomous rakers, I mentioned that to you as well. Our home essentially is trying that right now. Ice, we have ice in Canada, and we have our National Research Council. It says what happens when an autonomous ship gets stuck in ice or hopefully doesn't get stuck. So we're doing research on that right now. See what are the limitations of a autonomous ship actually navigating the ice. So, fortunately, non-unfortunately, we have ice in Canada, so we use that technology. We use that environment to actually test. And I guess for Superior, this is over, so we can probably do some cooperative work on that. Ferries, we have a whole bunch of ferries in Canada. Will a person go on a ferry that's basically operated by no one? Probably not. So that'll take a while before that gets accepted by the public. But we're starting to look at that. Firefighting, perfect application for a firefighting boat. Send it out and go fight the fire. So there's a naval architect in Canada called Robert Allen, who's the West Coast, and I think that they have a plans for a firefighting boat. I think have that. Spill recovery, that was mentioned yesterday, whatever. Send out an autonomous ship for spill recovery. It already exists. The rest have one. And these are all dangerous and dirty. I also use, thank you, Travis, I also use that as well. When you have something that's all dangerous and dirty, send out a ship that has no human fight. Use that. Important, remote control centers. So all these autonomous ships, the more advanced ones, will be controlled somewhat. And should we have some types of standards of how you control these remote control ships? You know, should the staff be a captain or basically a computer programmer that loves games? So these are questions that we're all asking. What would a control center look like, and what type of staff do you have in the So I mentioned Mayflower. So we have a TC policy on small autonomous ships. You can look it up on the internet. You will find the TP 135845. It's there. It's not hard. TC Transport Canada attends the IMO for looking at autonomous ships. So by the way, about several years ago, the IMO says, okay, how are we going to take care of autonomous ships? And then what they did, they started by saying, okay, we'll look at each of the instruments, and there's many within the IMO, to see if autonomous ships fit. Or can the instrument be modified for autonomous ships? Anyway, they put their hands up and they said, this is crazy. There's too many instruments to change, so we'll come up with something else. Captain Fuss mentioned, basically it's a performance of autonomous ships should do this, and this. And that's what the world is working on now. In the US and in Canada. So we can attend those meetings. When that performance standard is going to come, I'm not sure. By the way, there's something similar. It's called the Polar Code. So when you operate your ship up in the north, have something called Polar Code, which IMO, and it's sort of like a performance standard. So it'll be something like that. I'm almost finished. Blue economy. We use exactly the same words, the same buzzwords for the blue economy, the same thing. Right now, we're working on to get money from the Canadian government to develop autonomous ships for the blue economy, et cetera, et cetera. And there are many reasons why we should do it, but exactly. But the blue economy, by the way, came from Europe. So they're more environmental conscious. But anyway, it has come to work. So we're working on that as well. Thank you for the 97% of goods travel by water. I wasn't, I was way impressed. Yeah, I made a move. Matt, cyber keeps us up at night. These autonomous ships are hackable. They will be hacked. And our job is basically to figure out some types of technology to mitigate the hacking. Not sure whether we want to electrify the ship. It's interesting. But they will be hacked. I have a lot more stuff, but I fix it. So we have the same problems. So my goal here, by the way, is to tell you what's happening in Canada and hopefully to work with our American cousins on autonomous ships. Why reinvent the wheel? Actually, I forgot to mention this. We're working on setting up these living labs or regulatory sandboxes in Canada, where we'll be able to test on the ship. So we're going all the way from the East Coast to Newfoundland, Halifax, Montreal, Trois-Rivières, where there's lots of ice, and the West Coast. So I said, well, what about the Great Lakes? And the answer is, oh, we should be working with Americans that already have Mars, which we are here today. Why reinvent the wheel? It makes absolutely no sense. So one thing that I hope to get out of these meetings is some type of agreement with Great Lakes Research Center and Mars to work collaboratively on a living labs regulatory test bed, maybe do ice. I don't know what to do. I don't think we're going to do jet ski boats, that's what we take care of. But lakers, for example, automated lakers. We have the big boats, and that would be another perfect application. Thank you very much. I'll say it.
Thank you. Well, thank you all for the introductions. We've got about 10, 12 minutes here where we can take a few audience questions and then we'll break for some important refills and breaks here. I have one question that I'm going to save for a little bit later, but I do want to throw it out just to kind of frame some context to why we're having these panels. And that question is really, how can this Smart Ships Coalition, this group that we brought together and are continuing to grow, how can this group be involved in this process, working with our regulators and Coast Guard and Transport Canada to provide that really critical and needed feedback? So I'm going to throw that question out. You can answer it if you wish, but I'd like to turn this over to the audience to also pose a few questions in our time remaining.
Before we get a question, I'd like to mention our Coast Guard. So at one point in time, the Canadian Coast Guard used to be with Transport Canada, as well as ports, as well as air navigation, etc. So about 10 years ago, Transport Canada decided to divide and conquer. So all of these sections, the ports, the air navigation, whether it's a green port, they all got sent away to either other government departments or non-for-profit, etc. I think the thinking was get it out of government and it'll be more efficient. I'm not sure whether that's true or not, but that was the thing. We're getting back to Coast Guard. So our Coast Guard now is part of the Department of Fisheries and Oceans, and Transport Canada remains I call them the policeman. So we keep an eye on all of these different organizations. We set up the rules, the standards, the policies, and our Coast Guard implements these rules. They do have people that are working on the ships. Assuming they used to work for Transport Canada, but now they work for Coast Guard. And so we have been doing work with them on the same questions that us mentioned. We work closely with our Coast Guard. So that huge interest there.
Well, I can pick up on the question that you just asked, Travis. You know, as I'm sure all of you in this room know, the Smart Ships Coalition, it was really stood up originally to be this venue where everybody who's involved with smart shipping in the region can come and kind of collaborate and have this open dialogue. And, you know, to the greatest extent possible, it's important to have US and Canadian federal governments represented at that same table because, you know, with this really unique combination of industry and academia and government, both at the federal level and the state and provincial level, you know, this goes a long way to encourage future collaboration and, you know, have all the minds in the same room. And I think, as has been mentioned many times today, so I don't want to belabor the point, but, you know, this is particularly important from the regulatory side, and that's how we see it as an organization too. And the Smart Ships Coalition is a group that the federal government really should be looking to as a sounding board for these kind of smart shipping ideas to get initial feedback and things like that. So, you know, we as an organization have as a Smart Ship Coalition organization, we have a really broad representation, and I think that's one of our biggest strengths. And being able to the extent possible, bring all those perspectives into one unified voice so we can all speak with the same voice is super important if you want to get anything done. And that's something we find in a lot of our other work working with, especially the federal governments, is it's much harder to say no to an ask if everybody's on the same page. And yeah, that'll take compromise from some folks and risk from other folks, but you know, it's the easiest way to get things done, especially when you're dealing with unwieldy kind of federal governments.
And I'd like to just add to that. I think those are great comments. And even just hearing that from this morning, there's this interest in the Coast Guard to learn more and have a greater awareness about the Smart Ships Coalition and what its role is and who's participating and how to connect and engage. So I guess one of the takeaways and challenges I would put to everyone here today is that let's make sure we're connecting and we're identifying what are those strategies to make sure that we can make the Smart Ships Coalition the go-to for that information out and sharing these opportunities for coalition members to decide and feedback to federal agencies or state or academic partners or other groups that are here today. So I think establishing some clear roles and expectations on communication and what role the coalition can play to become that go-to and how we overcome barriers.
That's excellent. Thank you. Do we have any audience questions for let's see, I'm going to give it about another 6 minutes because I know some folks will need a break here. Yes, sir.
Is there any plan to bring in big IT players like Google, Microsoft, and so on and so forth, or and also some of the auto industry or autonomous vehicles and that technology?
Yeah, I could touch on that quick. And what I'd like to emphasize is that Smart Ships Coalition as a group is open, and we want to lean more on our members and participants to be making these invitations because we want to make sure that we have everybody here represented. So as we're thinking about this coalition and as we grow and work on developing roles and a sustainability model for this group, a big part of that is how do we invite the right people to be in this room, you know, so that at future events we have all the perspectives. So the short answer is yes, we would love to reach out to those. And if you do have direct connections, or if anyone does that, we could reach out to those folks. We'd love to have those shared with us so that we can make contact.
Travis, I'd like to add to that. So being small in Canada, we do many things. I work on drones, and we are working now with Michigan State. It's actually the Ontario government and Michigan State are working on a drone delivery corridor between Detroit and Windsor. And I think it's the Office of Electricity and Efficiency, I forget whatever it is. And they said, okay, we'd like to have this corridor going between Detroit and Windsor for drones. And we have companies like Amazon that are interested in that to transfer packages. We have the Ford Motor Company, basically, I don't know what they do, but just sending parts back and forth by road. I'm not sure if that's feasible, but anyway, they're interested. So you have some of the big players that are realizing that these are new technologies that can make deliveries more efficient. Listen, and mentioning that, I said maybe we should have the same thing on a smart shipping autonomous corridor between Canada and the US. Where that would be, I'm not sure exactly, but I think it's a good idea. And get funding from Ontario as well as Michigan State to do that. By the way, we do have 2 Canadian members of the coalition. We have Open Ocean Robotics that I mentioned, and we have Shift Environmental that was doing autonomous barge. I think the members, because I mentioned it to them, they came back to Travis and said, okay, we want to do this. Slowly, we're trying to make connections. Yes, but getting back, I think there should be some type of smart ship autonomous corridor between Ontario and Michigan. Hopefully.
If I could, just, Howard, what you just mentioned was the Innovation Corridor program in Detroit and Windsor at the air corridor. We also have a surface corridor, which we worked down in Detroit and Ann Arbor. And we proposed a marine innovation corridor to the state of Michigan. You'll see a poster out here about that. But that exact idea, so the state has created those innovation corridors for air, the drone air delivery, and the surface. And we propose a marine innovation corridor as well. And so that's the exact program.
Smart minds think alike.
It's
good.
Very good. Do we have any more questions from the audience? There's got to be one more.
So Travis, I would just add one thing with respect to kind of, the Smart Ship Coalition and kind of, growing the membership. As I mentioned, the great thing about this is trying to work through and build some consensus, right? And with the IMO, consensus is really what it's all about. You're never going to have everybody agree on everything. And so, I guess I would ask, does the Smart Ship Coalition now have some kind of seafarer connections? Because I think that there's really good discussion from some of the technology side of it, but we've got to be able to bring in those conversations and those perspectives of the seafarer as far as getting buy-in on using the technology. And then also when we think about the workforce, certainly we need to develop the STEM folks that can kind of be able to use the technology, but then we also think about how are the seafarers, as they continue to evolve, be able to do that.
Yeah, that's a great point, and we are certainly working on reaching out to some of these groups. I presented at the International Shipmasters Association conference a couple winters ago, and our message to them is we're trying to create an industry and an ecosystem where everybody's jobs are safer and more efficient. But we're really not talking about taking away jobs. We're talking about augmenting what we're doing on and around the water. And I know there is some apprehension among the workforce just based on maybe perceptions of what autonomy means. And I think as a group, that might be a really important point of outreach, is defining what is our goal and our common interest. We have ship owners in the room who could speak a lot to that, and anyone else in here that has those connections to the workforce. I think it would be really important to reach out to them, let them know what this group is really trying to accomplish, and inviting them to be here. So I think that's really a great and well-received point.
Again, we have the same problems in Canada. We have the same concerns. So we already started to reach out to our Seafarers International Union, Canada, the name of the person who came to give a presentation. And the pilots, these are the pilotage authorities, basically, the people, men and women that control these boats as they come into a port or go into a narrow channel. The message, as you said, Travis, we're not trying to replace your job. We're trying to make it easier for you to make your work easier and safer. And we want you to join us, not be something that will block us. Because the first comment, well, you're going to be taking away our jobs and that. You get that, obviously, but we're trying to educate them and say, no, we're not trying to do it. Trying to, again, make it easier and safer. You do your work. So it's very important. So we have started reaching out to They have been presentations on this. I'm not sure how much they have been. It's key. Without them, you're not going to do anything.
Yeah, and I think this is exactly the reason why the communication and everything is so important, not just between the US and Canada and folks in this room, but internationally too. You look at Norwegian Forum for Autonomous Ships, you see this huge smart shipping economy that's built up around Trondheim. It's totally revolutionized that area. And I think in our conversations with them, it's also important to talk about how they answer those tough questions. Because in their experience and in the experience of others around the world, this has been a job creator, not a job destroyer. And, having the framing, and I think this is the right framing, which is, we want to use these autonomous, like smart shipping technologies. We want to leverage what they do best so we can take advantage of what people do best. Does anybody really need or want to be on one of the, what do they call that, mowing the lawn, when you're out there just doing the surveying of the bottom of the lake? Like, that's part of my looking at stocks. Nobody wants to do that. So it's important to think of the ways that we can use everybody's time most efficiently, and that dull, dirty, and dangerous, stuff like that.
Well, that might be an opportunity to start to spin it in a more positive direction about the job creation and our step technology, green applications, and high-paying jobs that are in that field, and workforce development opportunities. So I think that's something to talk about more as a coalition about how can we start to tell the story more about this positive job creation opportunities of that future of our workforce.
And in some ways, we're certainly lucky that there are countries around the world, including Norway, who are more advanced in some of these areas than we are, because it allows us to look at what they did wrong and what they did right, and that helps us move even faster and helps these conversations come all the above.
Don't reinvent the wheel.
Well, thank you very much all for your input and feedback. And I think these are some outcomes from this conversation, or things that I hope we'll hear this afternoon when we break out into more smaller working groups to discuss things like the workforce development and the technology and policy. So let's keep all this in mind. Let's take a 10-minute break. We'll regroup in here, and there should be coffee and restrooms around the corner. So please help yourselves, and we'll see you back in 10. Welcome everybody back. So next here, we're going to have an industry panel and sort of hear some of the perspectives from industry and practitioners in terms of how autonomy is being leveraged or adopted, or even just various technologies within their organizations. First, I'd just like to introduce our panelists, and I will let them introduce themselves in more detail. But we have Eric Helder from Interleague Steamship Company, and we've got Steve Ruberg from NOAA, and we've got Sam Perez from Ocean Infinity joining us here. Gentlemen.
All right, I guess I'll start. First thing, if I sound congested, I assure you it's seasonal allergies. I tested for COVID. I can assure you it's not that, but if I sound stuffy, that's it. Like Travis said, my name is Eric Helder. I work for Interleague Maritime Services, which is a family of maritime companies here in the Great Lakes. We own Interleague Steamship Company, which owns 10 bulk freighters on the Great Lakes, including the Paltry Berth, which is the largest one, over 1,000 feet long, 70,000 tons fully loaded. We recently purchased a tour boat company in the Sioux Locks. They're ridden one of the companies we own, boat tours. The Badger, which is a historic coal-powered, believe it or not, ferry that runs across Lake Michigan, we recently purchased, as well as the Piermont Pet Ferry. And we're sister companies, same owners, with Moran Tug and Barge on the East Coast, which is the largest company in the Eastern Gulf Coast, as well as Eastern high-speed ferries in Manhattan, New Jersey, commuting ferries. And that, my role in that is Interleague specifically is assistant director of engineering projects. So in-house concept design, project management. You might have seen recently Prism Ship with Mark Barker. That kind of fell under my wheelhouse and my boss for the past several years. So very much an owner operator, and excited to be here and see how much technology will impact us as the end user eventually with this type of technology. So excited to be here.
My name is Steve Ruberg, actually a practitioner. I work for NOAA. NOAA's Great Lakes Environmental Research Lab. So I work for the federal government, but we use small autonomous vehicles to do research. The lab as a whole does things, for instance, like we developed an operational circulation model Coast Guard uses for search and rescue. That's an example of a product that we developed. So not only do we work on the physics of the Great Lakes, but we also work on things such as develop a epoxy model for the Cleveland water intake, the whole southern side of the Central Basin Lake Erie for water intake. And let them know when this hypoxic water might get into the water. So those are just some examples. My group in particular, the group that I lead, is Urban Systems and Advanced Technology Group, does things like satellite remote sensing, a product that some of the folks at this table use and the Coast Guard uses for ice breaking is a ice classification product. We use a Canadian satellite, actually, synthetic aperture radar. We create an ice product that tells where the really thick, heavy ice is. And then we also put out a number of research buoys, not the big operational NOAA buoys, but research buoys that feed into the whole observing network. And then we operate a number of small autonomous vehicles. A wave glider is actually here that we operate jointly with Michigan Tech. And then our Cooperative Institute, which is fully half of the folks in our building, they operate a number of different, Russ Miller and that group operates a number of different fluency gliders that are out there in various lakes pretty much all summer. Those are sort of the proven workforce systems. Some of these newer systems that we're putting out, such as a surface vessel, sea craft surface vessels that we keep on. We're just getting up to speed with. And we have other partners. Monterey Bay Research Institute is a solid partner, and we're also working with Hibbert and Shore to develop some capabilities to actually put these vehicles out year-round under ice.
Hi, my name is Sam Perez, and I'm from Ocean Infinity America. Ocean Infinity America is a subsidiary of Ocean Infinity Group Limited. Our parent company is a UK-based company. And I'll tell you, if you want to look at a group of people who are really serious about pushing the boundaries of where we're going with autonomous stuff, please go on the website. I mean, just the stuff that Ocean Infinity is doing is just absolutely spectacular. And I say this just from a mariner's perspective, not necessarily from a company spokesperson. So let me tell you a little bit about us. We were formed in 2017, and it was essentially from the recognition that a lot had not changed, or most everything had not changed in the business of oceanographic survey, search, and salvage. It started with the owner of the company going out and wanting to find a lost Spanish galleon. So he said, all right, if I'm going to go do that, I'm going to need some equipment. So we went out and said, what's the best out there? And he went out and got a great deal on some Hugans, 17 of them, as a matter of fact, and went out and found it. And as he was doing that, he recognized that there were opportunities to go out and conduct a business operation with the fleet of Hugans that he had. Of course, looking at it, Hugans 6000s were autonomous vehicles. So he said, all right, well, what else do you do? And as he started pulling the thread on the company and essentially the business model, he recognized that, wow, there are a lot of opportunities to introduce technology into this business model and make it more efficient. So essentially, we've come up with a model, and what we'd like to pride ourselves is we're a tech company that's transforming operations at sea to enable people in the planet to thrive. And in everything that we do, green is part of the question that we ask. Is this going to be a more sustainable way of conducting operations at sea? Everything that we do. So we went out and decided, well, what do we need to make this more efficient? Because the traditional manner of putting the equipment that we have out to sea, we thought was just not right. There's a better way to do that. We went out and contracted for 17 robotic ships, 4 smaller ones, 21 meter, 5 36 meters, and 8 78 meters. And we recognized later that we were probably going to need a little bit more. So we went out and designed some 85 meters. The 78 and the 85 meters just to show you how committed we are to green. Those will have hydrogen fuel cells on board. So they're going to take ammonia, put it through an ammonia cracker, and then extract the hydrogen. And they'll go through and utilize the hydrogen for the fuel cells that are out there. Probably going to be on station, or as you're on station performing the mission, probably transit is still going to be a diesel engine. It's going to be a hybrid propulsion plant. But everything that we do and everything that we're doing, we looked at it and said, how do you do this better? And every time we asked that question, we came up with the answer of, if you take the man out of the loop, the dull, dangerous, and dirty, it's probably going to be a greener, more efficient business. So we've done some pretty spectacular projects out there. We went out and looked for the MH370, didn't find it. And we're in discussions with Malaysia and Australia to go back and do that again. So we think that we've got a more refined solution. And with the fleet of humans that we've got, we think that we need to go out there and achieve some success to find that aircraft that has been missing for these many years. We went out and found the San Juan, Argentinian submarine that was sunk. And that was really one of those things where it shows how important the man in the loop is. Okay, we get it. Robotics is really cool and it saves you a lot of stuff. But the San Juan, the finding of the San Juan is one of those where it just shows you how that experienced eye in submarine warfare is called recognition differential. That operator looks at it and says, no, that's just not right. We had passed over the San Juan several times, and a guy named Andy Sherrill was looking at it, and he said, something, you need to go back and look at that again. Just not comfortable with that. And sure enough, it was on a really tricky slope, in a really precarious position, and it found it. So the autonomous stuff didn't work so well. It doesn't work as well as the human. In some cases, you still have to have that guy in there who go out and look at it and pull that needle out of the haystack. We've done surveys off the coast of North America and off the coast of West Africa. They're heavily invested in the hydrographic surveys to support the wind farms, the ocean wind farms. And we're also involved with oceanographic mining. We don't do the mining. We do the surveys before and we do the surveys after. So you can go ahead and characterize the field before you go out to mine it and afterwards. See what you get with that. How do you get from here today to tomorrow? Well, you got to make some pretty calculated investments. You've got to take some risks. One of the things that we did was we looked at it and said, okay, payload deployment, really tough operation. And when you look at it, I think, from my perspective, payload deployment is probably going to be harder than the navigation piece and the engineering piece. And let me tell you, I think the engineering piece is a really tough question, tough nut to crack. But that payload deployment, because you could be on 0 seas, 0 wind, a flat calm, and in no time, within the scope of a mission, you've got 12 foot seas. Now, how do you recover that expensive piece of equipment without making it look like it was in a bash curve? So we went out and purchased a company, Red Rock. It's a Swedish company, Swedish or Danish company. I always get the feed. Anyway, Red Rock does cranes and gantries and brows for offshore drilling platforms. So we thought, hey guys, come in, join our team, and help us solve that problem. We also went out and recognized that the software problem was a bit of a challenge. We went out and bought a Portuguese company called Vessel to help us with the software. The survey, we also went out and purchased MMT, a very large an experienced survey company, oceanographic survey company. So all of these technologies, all these capabilities that we brought in are all designed to push us into that survey, search, and salvage where we can do it robotically. And again, that's precisely what we're looking at, what the good captain was talking about, is how do you get to the point where you take the man out of the loop, you take it out safely, and make those operations as risk-free as you had it with the man in the loop. It's a really challenging question, as you all have heard here, and we're excited to be part of that environment plans.
Well, thank you for those great introductions. I'm going to kick off a little bit of Q&A with you now. I just have one question that I'll kind of combine a couple parts to. So I'd like to hear more about how your organizations learn about and evaluate new technologies for implementation and the activities you do as practitioners and as organizations. And then also, what are the challenges and the opportunities with bringing in one of these new major technologies?
I think for us as an owner operator, we learn a lot about new technologies through kind of being forced to. That's the best word I can come up with. But the regulation, there's regulation comes out, and we have to find a solution that we can upcome with regulation, whether it's environmental, which drives a lot of focus, as well as other technologies coming as well. So through that, we have worked with universities and colleges to investigate some proprietary research-based solutions. Some of this, we go to conferences with vendors to simply see what's out there. There might be something that we don't know. So that part of it is kind of fluid based on what the needs are. For all we have any time for you to go find someone, or we have people that call us as well. We're the customer to a lot of people that want to sell us equipment and stuff. The harder part, it's easy enough to find a solution. Usually it's what one is the best one and how do we implement it. Especially on the scale that we operate ships, there's nothing about them that's expensive. So if there's an environmental regulation that comes up, for example, like exhaust gas scrubbers, ballast water treatment is on the table. There's so many options. How do we pick one that will work for us? Because we don't want to throw money on a fire and put a piece of equipment in that doesn't work and take it out. That doesn't really benefit anybody. It doesn't benefit regulators. It doesn't benefit environmentalists. I keep going back to that. That's a lot of what we deal with, environmental regulation. It certainly doesn't benefit us. So for us, it's how do we methodically pick a technology, pick a vendor, and implement it into our ships, so that again, at the end of the day, works for what it was intended to do. Whether it's regulation based, whether it's an internal company decision to save money on an operational expense, it's how we methodically pick a technology that works.
Okay, yes, the first part of that that's how do we select, how do we get at new technologies? That's part of what we do. We don't develop everything, but we do some technology development on our own. And that's what we are as a research lab. It might be who does that, but the folks who are really out in front of this kind of thing would be like Woods Hole Oceanographic Institution, Monterey Data Footing Research Institute, a number of others. Michigan Tech University probably would be another one. Those we work with those folks to actually help us develop the challenge. That's it. So it's built in. It's what we do. And then as you test something, of course, new questions arise and you figure out better ways to do things. And again, I'm talking about small vessels that they put out there for research. The challenges, and any of that leading edge sort of platform that can get you data that you didn't get before is going to tell you something new and different about the ecosystem. It might help you develop a model that might be useful to some Great Lakes entity like water. But then the other part of that question is what's the part of that question?
Well, the challenges and opportunities, the benefits, I guess.
Yeah, biggest challenge that we have right now, or a big challenge, is we're shifting towards what autonomous technology has allowed us to think about is where we don't have ice hardened hulls with our research vessels. Autonomous technology is allowing us we've typically done small amounts of deploying sensors that go through the winter. Typically, you're getting one parameter or a couple of parameters or something like that. Autonomous technology allows us to think about sending a vehicle out through the winter under ice to get data about ecosystem fish, so on, and what have you. That's really not done. You would hope that we would have more information about what's happening in the winter, but we don't. So these vehicles are allowing us to begin thinking about how we can do that. We're really on track to try to conquer that challenge, the challenge of winter observations, so under ice.
Really great questions and questions that we've been battling with. So the how do you go about doing that? Well, the first way, as I told you before, we went out and looked at what was the industry standard. Who's got the best stuff out there? Who's got the brightest ideas? And you see that they've only taken it so far. And at some point, you're going to have to say, well, I'm either going to have to wait for somebody else to do it, or I'm going to have to do it myself. And in most cases, our company leadership said, well, hell, let's go hire some smart people and let's go figure it out. And that's precisely what we've done in most cases. For instance, Vessel is helping us with the software problem, and those software problems run from the navigational aspect of it all the way down to the engineering plan. From the engineering plan, if I need an ACE of O, an availability of 98% or 95%, I've got to make sure that everything that supports each and every single one of the critical components in there has an ACE of O of probably 99, because it all multiplies together. Okay? So that's a really complex problem, especially when you're looking for that remote operated valve that has an operational availability of 98, 99%. Finding those things is pretty hard. So getting to that point is pretty challenging. How do you do it? Again, we survey the industry, see what best practices, see what best products they have, and in some cases, you come up with the answer that you just got to do it yourself. You just got to build it yourself. And that's where we come up with the challenges. Well, just think about it. I mean, how do you do something that nobody has had, and you fail a few times? Okay, you fall, and you pick yourself up, and you get up and you say, okay, that didn't work, so let's go and try that again. I think we've got 2 Hugin 6000s in cold storage down in the Antarctic. Okay, we're looking for the Shackleton. Thank you. The Shackleton on the first attempt, and we left a couple of them down there. We'll go retrieve them at some point. But, right now, we count 2 in cold storage.
It's the endurance. It's the Shackleton boat. That's the
Endurance, right? Thank you. Well, anyway, so yeah, we've run across some challenges. Again, as I said before, I think the payload question, how do you deploy a payload and recover a payload, is going to be phenomenally different. Right now, there's man in the loop, but if you really want to push me on what I think is going to be the biggest challenge, is how do you convince the legislative branch to give us the permissions that we're going to need, so where the technology is at pace with the regulatory permissions that we'll need. I think it's going to take longer to get those regulatory permissions than it will to take the technology to operate effectively. We'll probably get the technology there before we get the permissions to go. I hope I'm wrong. And if I am, and I get an email from somebody someday, yeah, I'll give a toast to you afterwards at the end of the day, because I'll be real happy about that. I think that's a big challenge, and I think industry-wide, I'd like to hear from you all how we're going to get a lobbying effort, a cohesive lobbying effort, so that we can convince the unions, our legislators, the committees, the congressional committees, that we need to start moving faster on this. But we really need to start putting some energy into this, to give us the permissions and to give us the regulations that we need. So where the technology is lagging behind the legislative regulation.
Thank you. There's some great perspectives. I would like to turn it back over to the audience now to ask some of their questions, and we'll take maybe another 10 minutes for that. So please feel free to ask a question.
How many of your autonomous boats have been insured? I think we talked about it last time. That's one thing that bugs me. Anytime there's an accident, everybody would say, oh my God, millions just falls from the sky, kind of a thing. How do you manage those kinds of risks? Sam? Right now, we've got 2 vessels in the water, 78s, and those were built by Terry in their Vietnam plant or the Vietnam shipyard. And both of those, because currently they are manned, but we're transitioning those to unmanned or robotically controlled. Our concept is we're going to have a robotic center, and we're going to operate these ships robotically. There'll be someone, a master qualified, a qualified mariner, operating these ships from a control center in the UK. We think we're going to have one in Singapore, and we think we're going to have one in the United States. We're still trying to figure out East Coast, West Coast, but probably 3 control centers for the ships that we're going to operate. And right now, we're still trying to get with the insurance companies to convince them that, you know, robotics is still a good way. But again, it comes down to that, to the question. And they're still looking at it going, well, you can't operate with robotics. So you have to have people on board. Says, yeah, that's right. So we're still operating under the same paradigm, and that's going to have to change.
And for us, the federal government, we say that we're self-insured, which means that we lose a vehicle that's gone, we get it back. We don't have any insurance to cover it. That universities are in a little better position. They can actually claim the insurance claim. We haven't had an interaction with a vessel yet, and that would be a similar thing. I'm not sure what would happen with university with some sort of complication with vessels. The smaller systems are not as risky.
You have these centers in different locations, keeping a track of your vessel. It's autonomous. Is it not autonomous, robotics? Difference. Right, yeah. Okay, so whichever way it is, are you going to have a visual indication what the vessel is doing and how it is performing versus it's all digital? Visual and digital. So, in case of bad weather, like when you come to these parts here, I don't think very visual indication of what the vessels are doing, right? Just like when you're out at sea, you know, some days the weather gets crappy and you got nothing on visual, so it's all radar, sight, and sound. So in that case, I don't think much is going to change. There are some days when visual works great, and again, when we augment all of these things with IR and FLIR and all the other technology that we have. In some cases, I'd argue that I can get you a better picture than, you know, your tired lookout who's out on the fourth bridge wing, who's been, you know, just absolutely frozen for the past hour and a half, and is only thinking about getting warm, and getting some coffee, exactly, and making a headway. So, yeah.
Eric, did you have anything you wanted to add?
No, we're pretty, so I guess I should have gone a little more in introduction, but right now we have, we also use Buffalo automation on one of our ships. It's not even tied into ship systems. It's strictly a standalone that we're, you know, kind of our crews learning to use and see what feedback they have. And there's been some hiccups with that, but the rest of our ships have no autonomous technology on. So we're self-insured, we insured behind it. Very standard, you know, ship insurance for us right now.
Sure. Yeah. Excellent. I think we have time for one more question for this panel. Jamie.
Where do your organizations find the talent to solve these problems?
I think for us, and I'm speaking Interleague specifically, we have, myself and my boss were in-house, pretty dedicated to more design and concepts for future technologies to be implemented in our ships. And we by no means know everything, but we're tasked as part of that in-house group to find technologies, whatever it be, environmental or autonomous, to bring to our fleet and at least start exploring that. The other whole side of it is crewing. Each one of our ships has 18 to 23 crew on it. And you're seeing a lot of younger crew come on, and we're having a hard time getting people to come to that industry, regardless of technologies. It's a tough career to sit on a ship. How do you sell new technology, especially one that, on the surface they think could take their job away, to someone that's going to come work with that technology? How do you sell it to them? Now with younger people coming up, for example, the Buffalo Automation System, we have the crews in their 20s, 30s, maybe early 40s. They probably grew up with an iPhone. They see it as a tool to help them be safer at their jobs, help protect the ship, not necessarily something that's going to take their jobs away. But that's really the pitch we have to make to seafarers unions, to the maritime colleges, to the military academies even. I think I read an article recently where I think the Air Force or something is using video games as a twist to get people to come enlist with the Air Force, because everyone grew up on video games, flying a fighter jet. Now we can actually do that with a drone, obviously over serious consequences than Call of Duty. But how do you sell that to your workforce that's actually going to use it? I would say that's probably equally as hard as finding the technology and getting that tested, because that takes time and effort. Work with universities, do tests with a vendor. But how do you actually use it long term with people that do it? That's probably an equal challenge to actually get the technology itself.
So when it comes to technology development, we hire engineers to help us with that. It's pretty tough to get somebody with experience with autonomous vehicles. We tend to train them. For operators, we're looking to places like Hans's group at Northwestern College, where we're talking, they're graduating a number of technology related folks. It's tough, especially with engineers, to get new hires, because Google, anybody with the programming skills or engineering skills, Google's getting them paying them a lot of money, and it's worth it. Right? Even if we get them a federal salary, it's a challenge to get the folks. So we're succeeding, but it's hard.
From our perspective, it's a global search. And now that, connectivity has given us the opportunity to go globally, we really have taken advantage of that. And, when you look at it, Vessel is in Portugal, MMT's a Danish company, Red Rock's a Danish company. We're looking worldwide for the talent that we need in order to fill those gaps that we have. And we recognize, there's a lot of gaps, just in engineering alone. Reliability and maintenance of an engineering plant, if you want it to operate for 4 to 6, 8 weeks, autonomously, unmanned, that's a huge problem. So we cast the net broad and wide, and we'll take expertise from wherever we can get it.
Excellent. Oh, I think that's a good segue to our next panel, which will actually be our workforce developers. So I'd like to thank Eric, Steve, and Sam. At this time, we'll have Director Tim Havens joining us from the Great Lakes Research Center, Mr. Hans Van Simmeren from Northwestern Michigan College, and Emily Gotches from MySTEM Network. We'll kind of start with introductions, and then we'll do some Q&A.
It'll make more sense.
We know each other. All right, Tim, do you want to start us off?
Sure. So I'm Tim Havens. I'm director of the Great Lakes Research Center. As you all know at this point. But I'm also a professor of computer science here at Michigan Tech. I've been at Michigan Tech for 10 years and started as a joint appointment between electrical engineering and computer science. My research areas have been in sensing. Before I came to Michigan Tech, I did a lot of work with MIT Lincoln Labs in developing radar systems and optical systems for the Air Force. That naturally led to autonomy research, as autonomy research is pretty much sensing plus robotics, actuation, if you will. So the things that we've been doing here include sensing problems for Army. We've done quite a bit with explosive hazards mitigation, detecting things that are buried if you don't want to drive over, from several types of platforms, terrestrial platforms, and airborne platforms. And lately we've been getting into robust autonomy. So the idea of developing autonomous systems that continue to operate in tough situations, whether that's through just disruptions from natural occurrences, fog, or actually active disruptions from nefarious forces, if you will. And so that's obviously has been brought up multiple times here at the workshop, and is believed to be one of the biggest issues with the smart ships. I mean, we all know what happened with the Suez Canal. Now just imagine if there was 10 or 20 freighters that were clogging up a major shipping lane. That would be worldwide disruption of the economy. But, well, bad. Use an easy word to say. Thanks.
So, hello, everybody. I'm Hans Van Sommer, and I'm with the Great Lakes Water Studies Institute at Northwestern Michigan College. Our college also has the Great Lakes Maritime Academy, the Freshwater Merchant Marine Academy for the Great Lakes. My background is I started as a naval architect, marine engineer at University of Michigan. Guy Meadows, who President Kubek talked about this morning, and has been here with Tim and the team. He was my graduate advisor, and so my whole, I'll say, academic upbringing and research was around the development of tools and sensors to work in not only the 3Ds, but desolate areas, and work that we were doing in remote areas of Alaska where you couldn't bring a boat, you couldn't bring a device you can use in the Great Lakes. And so I look back, and Guy and I talked about this a few times, that the tools we developed were pretty high-tech in terms of data collection, data processing, but they were collecting and ingesting data and making sense of it. The BAPI boat, which is today's ASV, was actually it was a model ship that we tested in our tow tank from Sea Ray that we repurposed, put a fathometer on it, and then drove it around to collect data. And you think about these things now, they're commonplace. They've been on the screens all over. So it was always about how do you make something work for the application you're trying to do. And so when I left U of M, I got an opportunity to go to NMC, which Traverse City is my home. And early on, Kongsberg Marine or Maritime came into town and said, do you do any surveying? And while we weren't doing any survey training, hydrographic survey training, I had done some. And he said, what if we gave you some equipment? And so we went out with a multi-beam sonar, and we found a shipwreck in 400 feet of water that people have been looking for decades in Grand Traverse Bay. Immediately, employers started calling, so you're training hydrographers. We need students or we need graduates. And I said, no, we found a shipwreck, but what are you looking for? And it was whole, and I guess I look at this flipping the workforce problem. It's like Captain brought up earlier, that the question's the same, but the answer is different now. It's not about a degree necessarily, it's about a set of competencies. What do you need to do? How can you bring value to an employer? That could mean a degree, that could mean an advanced degree, but it also just means some credentials of value. So basically what we did is we listened to those employers and started developing what they were looking for, developed and cultivated a relationship with Kongsberg and now others to bring in those tools to develop people that could go out and do this kind of work in the marine space. And so hydrography, inspection, data processing, all these tools. And when you go back to smart ships, all these tools still require people. You still deploy them, you still fix them. And I guess one of the other D's, dependability, because they break. And so you cannot autonomously fix something. So you've got to have someone bringing in those skills. So from our space, what we do is really develop that technical set of skills that someone can not only be an operator, a collector, a processor, but then also a troubleshooter and someone who can get it back out into the workforce or into its job. So that's been very successful. We have multiple pathways, both academic, but also professional training at our college where we upskill current workforce. But it's 100% employment of all our graduates in the marine industry, primarily doing survey work, hydrography. And it started in oil and gas and then shifted all to offshore wind. And I guess one last thing is that when I first started doing this, we were heavily involved in ROV operations, and oceaneering was needing 40 to 60 people a year. And so we were developing specialized schools. And one of the things they said was that we need electronics and fluid power and some of these other skills. We really don't want you to teach them how to fly ROVs, we'll do that. But they need to live on Mr. Charlie, which was a desolate offshore rig that had been brought on shore that was like an onshore prison, more or less. You couldn't get a job unless you could live on Mr. Charlie for 3 weeks. So I'm like, how is that a skill? You know, and I get you have to live with people in remote situations, but with remote operations, with the development of autonomous systems, that's going away. So that whole mindset that you don't fit the culture of the group that you're working with is not in play anymore. And it's the idea that I could be at home, I could be in a remote office operating that same ROV for an 8-hour shift and go home to my family. And so you think about that from opening up a more diverse workforce, it really does open up a lot of opportunities. So that's where I'm really excited about and work with the team here at GLRC for many, many years, but really some exciting stuff that we're doing now with workforce and development of technologies and making those companions instead of separate. Thank you.
My name is Emily Gatchis, and I am a MyStem Network Regional Director. So for those of you that the MyStem Network might be a newer component of all of this, we are really focused on the PK, so pre-kindergarten, all the way up through grade, as you might think about it, and thinking about changing the system and educational talent needs, growing those talent out of it. MyStem Network is part of the Labor and Economic Opportunities Department at the Michigan, or in the state of Michigan. We moved recently there, but we're really one of 16 of the regional directors across the state. We have a small statewide state team, a central state team, but we also are in many different regions across the state, covering and connecting really to the K-12 schools, as well as post-secondary partners in those different regions in order to figure out, well, another really key problem. How do you create talent that can answer lots of great questions, right? We have these questions that are changing and at a pace where the technology is changing and the demand and the types of jobs that exist aren't even made yet, right? For our kindergartners or our 16-year-olds that are going to go into spaces. And at the same time, we know that we have a huge challenge around gaps in that talent system, and they really don't just start in the secondary world where we've maybe been thinking about that workforce development and that connection to employers and employability, but they start all the way down in kindergarten and ensuring that people from diverse talents from across our state or our nation, but we're utilizing the right kind of educational research, the right kind of partnerships and systems to really build out that work. So for us, what we focus on is collaborations. As I said, we're a small team. There's no way that you can ensure a pathway to a STEM career, whether that be a technical career, driving a boat, where you might need to be very STEM literate, or an engineer that might be supporting, doing all sorts of different jobs that I'm learning about today. I always like to be in these situations. So how do we create systems in place in our education world that are, this is a really different world that we're building for, and our educational systems are kind of old in some ways. So really trying to push our work with the Michigan Department of Education, with the Labor and Economics Opportunities Department, along with other state agencies, and all of you practitioners, post-secondary, to think about how to fill those needs. And we really focus on problem solving, project-based, and career awareness opportunities, making sure that all students have access to those. So it's a different kind of world that we live in. So how the problems that you're talking about today, helping ensure that our students can engage with those problems, engage with you to learn about the careers that are out there, and then to find out about the different ways to get into the systems. So computer science needs to be part of everything that we do. And yet it's only been a standard in the state of Michigan since 2019. So how do we train our workforce in the schools, utilizing all of you and our economic partners across the state in order to ensure those experiences can exist and so to train our educators, but also to ensure those student experiences are happening. So thank you so much to be here today. I'm looking forward to figuring out how we can work together and make it and help you get the future talent that you need. So we have a wonderful group of people sitting here in this room 25 years from now, having different conversations, perhaps different solutions, but similar.
Yeah, thank you for the introduction. So we've heard about these great programs and partnerships. We've heard a little bit about how they start and how they're evolving. A question I'd like to begin with is, how can we leverage a group like Smart Ships Coalition with this broad representation here in the audience to really help bring these programs to the next level? And what does sort of an efficient conduit to doing so look like for you all?
Yeah, that's a great question, Travis. I think, so something that a lot of universities are moving towards, and many of us have probably been a part of this in our education, is project-based education. So having students, they're not just sitting in a classroom with 150 other students learning calculus or going through problems that have solutions that they can look up on the internet or ask someone for the solution. But working on problems that don't have solutions. So the problems that we are all trying to solve. So rather than just trying to hire people and bring those talent into our companies or organizations to solve those problems, but reaching out to the next generation of the workforce saying, hey, here's a problem that we're working on, work on it. And while the students don't necessarily have the same experience and skills, or even the knowledge base that's necessary to solve that problem, it's really a great way to instill that knowledge base in the students. They get that education as they're working on the problem, and then they have those skills that are necessary to immediately hit the ground running within your organizations when you hire them. So one way we do that at Michigan Tech is the enterprise program. And so I advise the Naval Systems Enterprise program here. And it's a class that undergraduate students can take. They can start in their second semester of the freshman year, and then they can be in that enterprise program until they graduate as a senior. They can even do their capstone project in the enterprise. What's great is that we have industry sponsors, we have government sponsors. For example, Steve Gruber, NOAA is sponsoring one of our projects right now. And so he gets to work directly with our students, and he can then identify the great talent and bring them into his lab at NOAA and get actual solutions to problems that he's working on. So it's just really wonderful because the students get to interact with the organizations that they're going to be working in. They get the education that's topical. You don't have to retrain them to do things that you're doing within your organization. It's kind of like the old model of engineers. I remember I went to Michigan Tech, and they used to tell me, oh, you're learning calculus, you're learning physics, and these things may all seem just like they don't apply to anything. But what you're doing is you're learning to learn. And when you go get a job, they're going to teach you again what you're actually going to be doing. And it was like, well, that doesn't make sense, right? And it doesn't make sense, And so these kinds of programs, and I know that Hans is similar things, the green technology program at NMC is also that's a really strong component of why we want to work together.
Yeah, no, I'll just add on to that. Anytime an industry partner has come in and offered a piece of equipment and brought in the person who's got expertise in that, it doesn't have to be the most advanced model. The idea of teaching the process in an applied manner in a situation that actually real data can be brought back from, that is so valuable. And then that student goes back to you with their resume, or any company for that matter, with, not only did I mobilize, but I calibrated, I patch test, I collected, I processed, I delivered a report to an audience, and I presented it at a conference perhaps. And the whole point was, it's not research, but it's the application of the tools for research. And so that probably has been the most successful thing that we've ever been able to do. And so from industry's perspective, anytime you can come in and help with our programming, it's immediate benefit to the students in the school, but back to you as well.
We want to amplify those experiences at the K-12 world. You might not know it, but you can actually do that back in your regular public school systems or in after-school programs. It's amazing what young children can do. And that program, just describing these projects, this enterprise project that you have there, we actually have a group of high schoolers that are just across the bay, worked with some of our Coast Guard before, that are an enterprise program, the SOAR program runs under ROV, underwater ROV robots that are challenged by engineers here or other universities or local businesses, just for national government to solve problems. And that's something that's happening in a high school classroom where they're actually working to solve these problems and presenting at these conferences and been here. So what we need from groups like you, and many of you are already doing this, is really to be able to understand those opportunities to make those kind of experiences happen. They're gonna look really different in every single little classroom that's out there. So helping us join into your networks and communicate through those networks. And I think if there's the coalition is so much, it's more efficient and in general to be able to have those conversations, just like as a network, there's only so many of us, but we have this network of people that we would communicate to to ensure that those experiences are happening to K-12. So one, just being able to communicate with each other, but presenters in our classrooms or for festivals to help to inspire those. And then I even heard about, did I hear about smart ships challenges? Here's another example of something that can be done. And I know that Eagle has a great partnership right now going on with MTE to support and identify these types of programs that are happening in the classrooms, provide some funding for those. And then from that to understand and create a series of playbooks that can be used to support other school systems to get to that. So really partnerships, and all of you have many different places and to inspire these learning experiences that need to happen everywhere, just everywhere with all sorts of different people. And so it only will really be able to occur by learning about the challenges that you're having, these kind of communications and partnerships, and doing things like we're doing today to include K-12 in that conversation so that we can learn and grow together. We won't know what those needs are. And a lot of our educators, while super talented, need to be with you in the summer. So teacher externships, for example, to learn what are those careers that they're preparing, they're teaching that calculus for. Where is that going to go? And all of that is a long process. There's a lot of parts to it, and I can see, just having the formal conversations and continued partnerships to identify those programs being a key piece.
Awesome. Well, thank you. And kind of to frame this up, we're going to be having some working group discussions this afternoon that are focusing on everything we've heard about this morning. So workforce development will be one of those groups. We consider that a core pillar of what we're trying to do with Smart Ships Coalition. So before the hook comes out, because I know we have a lunch downstairs that's really nicely prepared, we've got about 10 more minutes where if any of the audience has questions or comments for this panel, please.
Thanks. Great discussion, and just connecting back to the industry panel, one of the great questions that I think we have is how do you change a culture? And what you all are talking about, I think it's fascinating, right? I mean, you're changing the culture down at that level. I think you have to put pre-K to gray, maybe pre-K to bald. But I think it's fascinating. I mean, even recently with my own daughter at the middle school level, with bringing word problems to solve in math, and I was like, wait a minute, this isn't what we're supposed to be doing. And she's like, Dad, I don't know how to answer it. So I'm like, me neither. I mean, sit down and we can work through it. And so I actually think that's really fascinating. So some of that discussion is especially many of our leaders in industry, many of our leaders in federal government are suffice to say, from a different culture. So how do you make that connection for what's kind of perhaps happening down at this educational level into those folks to help bridge that transition? I think I'm just excited. It's the way you guys are doing it.
So, Karis, I just want to build off of Emily's information that she was sharing. So, our office down at Great Lakes has been co-creating the freshwater book with ICE. And I think one of the opportunities that I see this conversation, is obviously what you guys have all been talking about, is an example of the exemplar showcasing those stories to other schools like this. But I think what we really need to continue to work on with this initiative is really making stronger connections for this industry for those projects, those opportunities for students, projects, for teachers to learn about these opportunities, and then also to just tie in some of the workforce qualities and pathways in the toolkits that we're building. So I'll be here all day. I'll have more conversation about what of these in the workforce development discussions. This is a big priority for our office, this partnership with FBE, Investor Network, and we also are super excited about it. We're doing our second round of grants to schools this fall. So we did a pilot phase 2 years ago during the pandemic. We're signing up, but we're kicking off through freshwater grants. And there, you know, there's a big focus on equity too. So we've got some projects.
This is for Hans. Do I understand that you're training your students for ocean air?
We have, yes.
Are you still doing it or?
No, not at the time. So this was pre-oil bust, 2014 when we started that. It came back with needing more again. They are hiring them, but we're not doing specific training. So what we've done is just develop the degree platforms and the graduate pathway for that. So they come now and recruit, but not specific targeted training for a specific set of jobs. Yeah. Thank you.
Steve.
Yeah, so maybe from everyone, how are you reaching out to folks that we don't include in our workforce this diverse? Get them in diverse workforce. Then a separate question. Tim talked about the bias and sensibility around other opportunities for sort of federal or industry or whatever to maybe have projects that students can work on. That's
Sure. So how are we reaching out to ensure? The great thing I think about so my background is really as both I've had a science hat on for many years. I just graduated with my doctoral degree, the geoscience department here, but at the same time have been a high school science teacher, an outdoor educator, and other ways to inspire youth. And I think one of the things that I really love, and the reason why I got into both of those fields is about problem solving. And so, and this is a major problem for us. How do we reach all of you? You know, we have just such incredible talents, streams out there, ways of knowing from these different communities. And as we're speaking about culture, it's a huge shift, right? We need to affect all cultures and help to build those up. So what I love about the MySTEM network is that we are connected with all schools. You're talking about trying to utilize collaborations in industries to really ensure both at the state level, but thinking about them differently at regional levels and pulling together our economic development groups, the fact that, and others across, you know, really pulling everybody together at a regional level, but also at that state level, and then and looking to form these coalitions. It's not going to happen without partnerships. It's really that networking that'll need to be ensured in order to strengthen and create transformational partnerships that allow us to meet those needs. But at the same time, it's about what we're putting in front of the students. So what are the learning experiences that we're putting out there? I love designing relevant learning experiences, whether that be for adults, all the way down to kindergartners. I'm learning, it needs to be my talent, but it's working on it now. So what about it that's relevant, that allows them to do something right now in their own world as part of their school day to affect change. And that helps them stay in the game, stay interested, create a STEM identity, whether that goes into research or whether that goes into some kind of technical career that will utilize those STEM skills. I think that's really the key. And so we can't do that alone. So that's again why we're here, and then trying to foster that network of all of those great partners and experts that are doing learning experiences every single day with your children or your industry's children, and figuring out how to bring everybody together in a space to just create those learning experiences for those students. So that's, I think, for how do we reach them, that's that collaboration and then engaging with everybody.
we started an early middle school college program with a local charter school. And the idea that they, through their 13th year of high school, will obtain our marine technology associate's degree. The idea of then trying to capture that audience to move on to wherever that might be next. Could be our bachelor's degree, could be coming to Michigan Tech, could be coming to any university involved around that. And we want to try that. We want to see how many we can capture. And then we've really put a focus on the career technical centers at the school districts around our area and the ISDs from a broad perspective, but engaging them not just from a get out of class to go somewhere on a field trip, but embed them into what we do. And that maybe that feeds into what could, like what we work with you at the Gloro Lab. And some of those projects are just absolutely fascinating. Like we talked last night, that the sinkhole work brings in so much STEM discipline, not just technology, but the idea, how do we build that into like the Explorer projects that NOAA puts on the national level. Like we can do something like that in the Great Lakes and engage a lot of communities.
Yeah, just to add on that, you know, from the perspective of like graduate programs, one of the things that we do at Tech to broaden the participation is it's called the MyStar program. And so we bring in students over the summer to work in professors' labs with their graduate students, working with PhD students, with postdocs, with research scientists. And so those students are coming from like the historically, what is the, help me, Emily, you're really good at these acronyms, HCBUs, HBCUs.
Underrepresented, at the university, sorry.
Yeah,
Historically, yeah.
HBCU.
Yeah.
I won't.
But I think you mean underrepresented community, or historically underrepresented communities in general.
In general,
Yes.
yes, thank you. And so they get these experiences and they get to see what it's like to do that graduate level research and work with professors on this high risk, high reward research that's funded by industry, by government agencies. And we have a really good track record of actually bringing in these students then into our graduate programs. Excellent students. And so we can make those connections. And to answer, you know, that kind of leads to Steve's second part of his question about, you know, how else can we integrate or interface with industry and agencies? So the Great Lakes Research Center in particular is an organization on campus that operates, I would say, more like a business than it does a university, and that we are a self-funded research institute. So all of the activities that we do here at the Great Lakes Research Center are funded by external organizations. What's nice about what we get to do as opposed to, say, industry, is that we can simultaneously do research that is much more placed, I guess, to use Steve's word, practitioner research. So going out, running an AUV to collect data, passing that data on to the community, making it publicly available, but also then interfacing with faculty who are on the leading edge of doing high risk, high reward research. And so have that, you know, that myriad, that full spectrum of research that's going on. So, you know, we'd be happy to talk to anybody about funded research, and you know, and that kind of, just to put kind of a blunt summary on that the last question that Travis had about, you know, how do we, what are some things that universities, workforce development, industry, is that we really do need funding. We need funding and we need stuff, as Hans said, the equipment. And I always feel like professors get that reputation of just always asking for money, but it's true. I mean, it's the truth. But what you get back out of that is access to that next generation and fully trained workforce, because you're working with them directly, often on a weekly basis.
And to add to that, I would just say not only funding, at least all the way through K, schools need it as well, or your after school programs, but coordination in that funding, I think it's really key. So there's a lot of different ways to engage with partnerships. You guys are industry, or if you're any kind of employers or government agencies, everybody's really busy, right?
So being able to find a coordinated space and where each group can engage and when to engage, I think that's the space that we could really dive into with this. And this is a great example of that for us, because what now is STEM-rich business, right? And so whether that be, if it makes sense to do, cybersecurity student camps, or if it's to, inspire people to do their career and technical education programs, which are full year connections across the state that exist, or if it's to get some kids excited about math through a math circle. These are all things that are taking place right here, in these universities. So that ongoing sustained support for these systems is key. And as you know, our political world can sometimes make it very chaotic for these systems. And so to be able to coordinate together in order to ensure that that support is there, it can be ongoing and continues no matter what happens in with our legislative branches or our world in general. To be able to fight through that, we see the fast partnerships come out of things like the pandemic. When they're long term, we can really make some great things occur. So just thinking about how we can inspire those, I think is key. And funding is certainly